Start that. I'm going to switch this over and start that. Okay. Okay, broadcast. Okay, we should have all systems. I think I've got all systems going here now. Let's double check. Bear with me a minute. Okay, YouTube, Facebook, Zoom, live stream. Okay, I think I'm ready to begin here. Welcome everyone to the Keshe Plasma Reactor Group. Once again here, Tuesday my time, but everywhere else in this universe seems to be Wednesday, September 12th, 2018. And in the Keshe Plasma Reactor Group, you might think we would talk about Keshe plasma reactors, and you're right, we do, amongst other things. And we shall see what those other things are as we go along today. So let's get things going here.
You can put me up as a co-host if you want.
Thank you, John. I'll do that. And I've got some attendees to bring in here. And there we go. And let me unchime that nasty little chime. All right. Now I think we're really and truly ready to go. Okay, so let's begin. Is there anything, I always ask, is there anything anyone would like to present to start off today's festivities here at the Keshe Plasma Reactor Group? Has anybody flown to space recently or had other more down-to-earth experiences, perhaps? I know John was talking about a couple of things before we began here. But if there's anyone who needs to go ahead early, then they can do so as well. Okay, John, maybe you want to talk a little bit about this interesting idea of car washing. What does car washing have to do with Keshe technology? Do we have to start a Keshe car wash? The GAN's application car wash, or the
Jalal can experience it at his job.
Interesting. Yes, maybe that's anyway, you should brief people on what we're talking about before we get too esoteric about it here.
Fine, I'll get down to it. I've got a friend here who comes every other day to fetch water and is very friendly with it. himself and his wife, and a bloke from Buenos Aires here, from Argentina also, let him know to try this out. So he did so. He was washing his car, so he was told not to dry the water off the car, and just spray some Gans water over it, and don't dry it. Let it dry itself. So he did this, and then the next day when he used the car, he noticed it was very much smoother on the road. We got cobblestones here, and well, the roads aren't very easy on our tires, let's say. So the car wobbles a bit, and it was very much smoother on the road. And he's also tried the Gans water and the Gans sticks on the battery for some time, but he had to renew them. And he's also tried beforehand the Tesla coil on the petrol pipe, and he's got to put that back on because when he took the car to have a service, he took all those things off for not to have any problems with the agency. But well, the commentary is he felt the car very much smoother, and he was told this from Buenos Aires, and he practiced it and had very good results. So it's a question of trying it out ourselves, huh?
Yes, thank you. I just realized my audio is not on in the live stream for you there. So I have to just briefly recap that John was discussing about washing a car, and you leave the water on the car when you're done washing and spray it with Gans water after that and let it just dry naturally. And the results were that the vehicle seemed to be much smoother across rough roads and so on, and drove better. So this is interesting. I wonder if the gas mileage would also change. That would be interesting to take a test of. Some people have reported such results.
Well, this happened last Saturday, so he hasn't had much of a way to realize if his consumption has gone down. But well, we'll see what news he has in the next few days.
Do you have to wash your car all the time to keep the gas consumption less?
I've left my car in front of the house for the last 15 years. I use a motorbike right now, so motorbike. And the other experience is another friend of mine, as years ago here, we had an experience is people tying a bottle of clear water on the pipe that brings the cables into a home, and the commentary was that the consumption dropped down. That never really happened. This was over 20 years ago. But then we remembered about this, and so I said, "Oh, I'll try it out." So I got hold of two small Coke bottles and filled them with Gans water and a bit of Gans, about a 3-to-1 ratio, and tied them to the cables that come into the house. And apparently, for the last 2 weeks, I've had a reduction of about 30% in the consumption just by tying these two bottles against the cables that come down into the home, the power cables, no?
Yeah, that's an interesting idea. Imagine if it is true, and if you could verify that, then others can run that experiment. What a quick and easy way to
Magrav, yeah.
decrease your energy consumption, and probably create some beneficial fields at the same time, or perhaps protect against some of the less beneficial fields of the electricity even.
Yeah.
Interesting.
Protect your home and reduce the consumption. And it's a very much cheaper Magrav.
Mm-hmm. Yeah. Very
Yeah,
simple. What Ganses did you use? A combination of Ganses or any
ordinary
particular?
CO2 zinc oxide.
Oh, okay. No copper,
No, no. Well, there may be a bit of a copper, but
just
very,
residual. Okay.
yeah, because the big problem here right now in Argentina is we've had a very big devaluation. The dollar has gone up to double the value for us, and we're having a hell of a tough time with the devaluation and what you call it, the increase in the prices of all our goods. So,
People
but
are going hungry and whatnot. I
yep,
understand. A lot
yep.
of people.
In this country, we have no problems with food, but we have a hell of a lot of people going short with shortages of food and what have you because of the culture. I mean, every 10 years, Argentina has had this big problem. We've had it for the last 70 years. So, well, we've got to live through it, but it's good exercise for whatever other problems that occur in the world. Huh?
Mm-hmm. Yep. Well, I wish you well. I hope you do. I hope you prosper through it in one way or another. It may not be financially through this time, but perhaps there's other ways to elevate oneself and just keep maintaining. I think
A
what you're
lot of
doing with working with the Ganses and interacting with others that way is helpful. When people discover that they can tie a couple bottles of Gans water to their electrical wires and make significant savings, that's a pretty big way to be useful. Okay, thank you, John. Anything else you want to relay about that?
And I have no other ideas right now. We'll see. It's 2 in the morning for me, so it's strange hours. But I'll see if I anything else crops up, and I'll let you know.
Okay, thank you. Alrighty, is there anyone else who has something they would like to bring up, present, discuss, or otherwise dissect in this group? Dan, you have any experiments you're running lately? Anything you want to discuss? Anybody have any questions that have come up in their studies of the technology that maybe somebody else can help with to answer? Or oh, I've got an attendee to promote the panelists here. There we go. And just checking for questions in our streams here.
We could mention that we have a new version of Zoom because I see many of them haven't renewed Zoom.
Yes, indeed. That's a good idea, John. I think that came out last week, and or at least for the Mac it did. I'm not sure about the PC, how that worked out. But yeah, there's a few people here that need to update their Zoom. Might find things work a little better when that happens. Sometimes they're small updates, sometimes they're big leaps for mankind, humankind, womankind, all the kinds. Okay, no questions, no presentations. Nobody wants to talk to me. Should we shut down for the night? Do I get a night off? Finally, after 5 years at this, I get a night off. I hear a pillow calling me. Surely we can inspire each other here. Takes a while to get things warmed up sometimes. So let me see. Let me count the ways. Oh, Jay has a space-based question. All right, let's go with that in the chat. Jay says, Rick, I have a space-based question. It's about pictures online about Mars. At first, Mars looked red and barren, but today I saw pictures of it with a blue sky and even now with clouds in it. How can a planet change so quickly? I wonder if it's being terraformed, or is it really habitable for humans? Where did all the clouds come from? Well, there's been weather on Mars for sure. Mars has a CO2 atmosphere. I think it's about 20% of the density of the atmosphere of Earth or something like that. So it's a fairly light air, you might say. It'd be like air up in our, maybe up at 30 or 50,000 feet or something on Earth. And high in CO2, and it's got winds that blow the dust around. They just had a huge dust storm there that wiped out the Mars rover, and they lost communications with it because of the dust storm, and thus cleared recently, and the little rover kicked back into action, and its solar panels are now working, and it's powered up, and it sent some pictures back of itself. It sent a selfie back. So definitely there's stuff happening there. I don't remember blue sky or clouds in the pictures, but that could very well be that they would. I know they have, they're showing, I think they discovered a large lake under one of the poles on Mars recently.
Although possibly earlier photos have been filtered for public to be everything red, while there are plenty of colors there, eventually.
Could very well be. So yeah, that's where Elon Musk wants to retire on Mars. He's got Mars flights planned in a few years for humans, so we shall see. It's his big idea is to get people to Mars.
Anyway, Mars looks like a planet devastated by a nuclear war or something like that.
Yeah, that was actually one of his ideas, was to set off some nukes on Mars in order to create an atmosphere and so on. You can warm it up, and the CO2 can convert to oxygen or something. I don't know. There's some process there that. And they might be busy wanting to terraform it and so on. I guess there's problems with that too, because it's not the same as terraforming on Earth, and it will completely destroy any known. It wouldn't work, basically, is the way I understand it, the way it would on Earth. So they can't terraform so easily. Anyway, I don't know all the ins and outs. Be nice to shoot by Mars in a spaceship, make a flyby, and wish them well in their little adventures.
Rick,
I don't see it as an end destination that I want to spend the rest of my life with, but some might. What's that, John? Sorry?
I've got a question for you. What is that red blinking light you got behind you? Goes on and off. That red bulb and on the line of the KFSSI ad, you got it here in the middle.
Over here?
Yeah, that red bulb goes on and off.
Oh, is it? Hello? It is. Are you sure? Maybe it's just a reflection.
Oh, maybe, but it's very peculiar.
Oh, I think it's the light is going on and off. I think it's like the autofocus or something here. Let me see if I can rectify that. Let's turn the auto. Oh, yeah, the white balance is.
We've got a bit of Jay's humor here. He says it's the on-air light.
Yeah, I guess so. Well, it's funny because this thing will. It actually does light up and everything, but I don't think it's plugged in right now. So I'm just
Out of service.
wondering why the heck it would even. Yeah, it's not even plugged in. So it would be very unusual if it was lighting up. That's what I was wondering.
Must be Tesla sending you some signal.
There we go. No, it's the there's something screwy with the camera. It's kind of its white balance is not sure what to do. So maybe it's, I think it's getting too much light, maybe from that upper light there, and it's upsetting it. Maybe that'll be a little bit better.
Alper is letting us know he's got something interesting in his hands. Let us know about.
Is that interesting? Oh, sure. A thing in the GANs. We like GANs things. Sure. Go ahead, Alper. Take it away.
Thank you. I can't start my video.
Oh, okay. Let me make some adjustments. That should work.
I'll reverse it in a minute. Okay, I'll do it. Now, tools, inventions become tools, and then those tools become inventions, and then again, inventions become tools again in our understanding, and I have no idea. I have a couple of tiny, not even ideas, is something up in the air, but I have early photo. It didn't have that much, and in this consistency. Now I'm thinking up to this area is just rust, and this area isn't, and copper, you can see the copper color. But when we focus on this part of it, it is rust, and copper let out itself somehow. I've been using this screw for a while. It was showing some rust, but not this consistency. And this came down out of that. That's what I think. Would that be a rust? Gems of rust? The gems inside the jar, I can't remember it, what it was, the story of it, but it's written on the, I always write it, it says the middle GaNs. So I assume is CuO2, but this isn't. I've left it years ago. I've looking. I cleaned it, of course, at that time, as much as I could. I do it really nice. I think I do it nicely. It wasn't this color. Maybe I can't remember it, but now this is gray and some orange things on top of it.
And
yeah,
is it in salt water, first of all?
it shouldn't be. I thought it was clean plasma water, and I put it into this container from supposed to be the clean plasma water of the middle container, which is, to me, indicates a CuO2, and which supposed to be bluish, really nice color, but it's gray now. I'm not sure. Maybe I have made a mistake. Maybe it has changed itself over the years. Very fine dust, I'd say. It's like, it's powder. I don't know what it is. The gray part of the surface I'm talking about. The orange parts, I have absolutely no idea. And dripping from the...
Is it
pardon?
Yellow? Is it more yellow than orange almost? It looks quite yellow in the picture. And
it is
like,
yellow.
It doesn't look like the orange hemoglobin rust kind of stuff that comes off of nails normally, right?
For sure. As we can see, like in the middle, there is that little depth, turns into an orange color. Maybe it's the depth of it gives us this illusion, but it's mostly orange. That's what I see. And it's like a candle. It accumulates and it stays where it drops. Like a little city down there.
Is that a screw or a nail or what is that? And does it have a copper or wire wrapped around it, or what did you do there?
The screw contained zinc previously, and I rolled copper around it, copper wire, very thin copper wire around it, in partially simply without really caring, but thinking, feeling, hoping to be in line of everything. It's really a thin wire, so it was very difficult to roll around it. But please go ahead.
Was the screw, are you sure it was a zinc plated screw? Maybe it was chrome plated? Could it have been chrome? Was it shiny? Was the screw shiny when you got it, like shiny, bright steel, shiny, or was it more zinc colored, dull sort of gray?
I wouldn't really put it right. I wouldn't establish which is which really, but it is a possibility. I can't say it was the zinc one.
I've got one right here. Let me demonstrate what I'm talking about.
Please do.
Let me take over the
nickel.
Let me take over the video briefly.
Please
here.
do.
Like, this is a lag bolt, a similar screw with threads on it, right? You
Quite similar.
You can imagine a similar thing. Well, this is a steel bolt, but it is chrome plated. It's actually got a plating on it, so it's, you know, bright and shiny. It's not zinc. Zinc would be a similar color, but dull. It wouldn't be all as shiny. It might be more mottled looking. But you can get lag bolts that have a zinc coating and ones that have a chrome coating. Now, when
you're right on that, I think.
When you get when you have chrome, what happens is the chrome ends up creating a yellow-orange like material from the chromium. So that's something that you might...
That makes sense.
And keep in mind that's extremely poisonous, chromium. So I wouldn't be ingesting that GANS water, for example.
No way. No, I wouldn't.
Yeah,
I
don't
wouldn't
touch
do
that yellow stuff, because that could be... Oops, sorry, my sound was off on the live stream, and I messed up on that again here. So I was just, jeez, sorry about that on live stream. I was just saying about this is a chrome plated bolt as opposed to zinc plated, and you can get them zinc or chrome in the lag bolts or screws. And that the chromium will, under certain circumstances, create a yellowy, sort of orangey yellow GANS-like material from the chrome, and that it's be fairly toxic, so you wouldn't want to be ingesting it, I would say. Anyway, back to, let's go back to your picture there. And
partly corroded, as you can see. I just put the light to be able to show it correctly, but interestingly, some part really rusted, and the wire is holding on to some of the yellow things. And I just tried to roll it all over the place. And it's attached to another capsule of GANS, hoping to get more interaction, really, and to see what would happen. I have tons of GANS that I have been keeping it for a while, and I'm using them one by one to put in this container, and to see whether tools going to be turn into an invention, and invention is going to be tools. That is what I'm trying to do, just to push the envelope further and further. Totally no CH6. Okay. Just experimental. I just wanted to show it quickly.
Thanks, that's cool.
Right next to it, I tried it with the ocean water. Same experiment, connected to each other, and nothing happened. Not much to see there. I've added salt in it, whether to have more interaction and some kind of batteries, as you know, but no, there isn't any significant result. But with this, I see the yellow, as you warned me. I'll be careful. I'm sure it wasn't zinc, even though what I thought was, previous experiment I thought I collected some amino acid on top of it. That was like also a candle glue type of, like, very buttery and white thing. So that gave me that was definitely zinc. So I created the higher GANS condition and received amino acid on top of another solution. Of course, it wasn't this at all. I clean it and I try it again and again, and I give some energy into it, batteries, and I stop them. I even put some other, well, I call them reactors. They are individual reactors to me. Some of them are emptied due to, I have no idea. It's all over the place, but I'm trying to keep a track of it as much as I can. See the effects of it, move it slowly, or use it, one of them, use crystal, use this item, or not use it. I thought maybe I could place a little ping pong ball in the middle of it. Those kind of experiments are very useful, just to inspire you. Hope you liked it. Thank you so much. various cores contains in these. By the way, there are there are three of them. Yep, that's all. Sorry. Yep, go ahead, Rick.
No, okay. If you have more, go ahead. If not,
I think I've done it all. Thank you.
okay. Any questions for Alper before we let him go here? Interesting. Let me show a picture of the Wikipedia on chromium, and
Please do.
I'll show a couple things there. So I was mentioning about chromium, and this is in Wikipedia. Chromium, sort of a silvery metallic substance and so on. Talks about all of its ins and outs. And then you get into some of the pictures of what some of the materials look like. And the one that came to mind was this one. Very bright yellow.
Very similar.
It's called sodium chromate.
Oh, wow.
So we know we have in the we have sodium in our
always accumulated.
We have sodium oxide we work with. We also have sodium chloride. So there's two sodiums, both the salt we use and the hydroxide or lye or whatever you like to call it.
Sure.
So it's interesting that there's
a
special process that they use to make that, but it seems they mention it here. I think it's the roast chromite ore with calcium or sodium carbonate.
Okay.
So it's possible there's something in the ganses. It mentions that you can get different colors. It can change from yellow to orange.
Sure, it does kind of in some areas. Yeah, you can see that. Yeah.
There's potassium chromate as well.
I was planning on drying it and burning it to see the color of it to be able to determine it.
Isn't that interesting? That's the ball and stick model of the chromate anion. That's that's what chrome looks like. Our
absolutely
star configuration, the tetrahedral configuration with the free plasma in the center, essentially.
That's pretty amazing. That's like the division of it, even the gray areas and the red areas, and the sort of interaction that kinds of follow. It's pretty much there, I think. I don't know.
That's pretty wild, actually.
It is. That's very significant.
That's CR, chromium is CR. The CrO4. That chromate is CrO4. So those reds that we see, those four reds. Go back a bit here. Those four red balls are oxygens, and the chromium pulls them all together. It attaches to four of them at once. Interesting.
It's like it's all one, but five different parts of it become one body. And
yeah, and then it can join together with one of its friends through a common oxygen bond, or a common oxygen atom, and two of them play together as a dichromate. So that maybe that's a clue how we can join two reactors.
Yeah, that's what I was going to say. That's brilliant. Yeah. And forever it could go.
So one reactor would be shared between the two systems, basically.
Absolutely. Yeah, simply as that. Yes. That's just wonderful. Yeah.
Okay, so
that was a very,
yeah,
very
school
correct.
buses are painted in chrome yellow, it's called. Yeah.
I love that.
Okay, so anyways,
Thank you. It's very good.
it mentions that the chromium compounds are toxic due to their oxidizing power, because that one we looked at, for example, this is a -2 charge on it, and it's very powerful ion that would tend to attach to other things. And
it is, if you look at it into its complexity, even with this example, it almost has its own structure developed immediately in a couple of days. I mean, I have tried different gens in it. What happened was, as you see, there is another thing on top of it. It accumulates salt, simply is that, just under it in the jar part of it, and then they drop off. I thought it was this in the beginning, but it wasn't. It was pure yellow, and I'll share the early photo. It wasn't this much. When it started, when I turned this off, and it started accumulating a lot.
Let me stop the share so that we can see what you're doing there.
Yeah, not much, but
didn't do that.
So
right.
I didn't have anything in the middle, and I just had the right bit, and I didn't even have the one on the screw. But what amazes me more than this, how the blue CuO2 turned into this gray color in the meantime, after a year, I would say. It says it on it. I write it really simply, so I'm pretty accurate what I mention on it. And so that was a mystery. That's the beginning of the mystery to me. Would that be possible where I store them next to each other GANs all together, and would they continue their effect on each other, and eventually after a while, years and years, and they find their best position, I would say, and then they change the color. Sorry, that. Yeah.
I'm wondering also, maybe it was some CH3 GANs that turned into deuterium or something like that.
It is possible, but I also think the other containers, where I put how I contain them, would definitely have an effect on the GANs that I want to preserve. So if you like to keep it as it is, as you have cleaned it and just ready to store it somewhere, maybe it's not wise to put it with the rest of the CH3 or with the rest of the CO2. Maybe it should be kept on its own. Just to tons of questions. I have millions of questions, and just pondering and wondering.
Well, that's a good point. Mr. Keshe has brought that up lots of times, of course, about keeping GANs as separate, and it may require them to be meters apart in order not to have a direct influence. So, yeah, interesting.
Definitely. Thank you.
I can add, I've had a similar experience. Copper oxide, the light blue or turquoise color, changed to a brownish, grayish color with the time. Yes, I've had a very similar experience.
I'm sure. Yeah, that shows the right direction, I believe. If you have the same things happening all over again, that's what I see every time I watch it. that gives me the direction that yes, really.
Okay,
And-
so we have to get clear for Jay here. He says it's hard to tell what's going on in Alper's picture. Is the red stuff the GANs or the gray stuff? Is the red stuff the table or is it the red GANs? He's confused there. The red's just the table, correct?
Surface.
Yeah, surface of the table. And the gray
gray stuff supposedly to be the cleaned CuO2 GANs plasma water. It should have been over the year. But when I poured it into this jar, it was a very cloudy water, very muddy. It settled over the time and it has started interacting with whatever around it, and then it produced this yellow substance on it. What I thought was interesting was the intricacy of the accumulation of it, and that's what I wanted to bring it up. I thought maybe a little city down there, but truly with the Mr. Rick's information, that is the interaction we see there is really nice and significant.
And it might change color. It might turn into, like, if the chromium plating wears through, and eventually it will, then you'll probably start getting a more reddish, a deep reddish material coming out from the iron that starts, because you've got like a little galvanic battery action happening there, and with the coiled up wire especially, it sort of amplifies the voltage and so on. So you've got a little system that's trying to, it's extracting the materials from it because of the interaction of the field. So yeah, it's interesting. How long has this been going on for now, Alper? Like
1 week.
Just a week? Oh, okay.
Just a week. Yeah.
Yeah.
I'll
But
share the early photo of it.
The
Pardon?
GANs you had longer though, didn't you?
Pardon?
Didn't you say the GANs you had for a long time?
The GANs I had it over a year.
Okay.
All the GANs I have, I produced immediately as soon as I learned everything, and I continued doing it a year, and then I eventually had to stop because I had too much of it.
So
and
you put the GANs in the jar with some fresh distilled water, or was it just the GANs water from the
GANs that I store are they're cleaned with, filtered with the coffee filter, and using distilled water over and over many times, so that I would get the GANs of it, the solid particles of it attached on the surface of the filter, and then I get the water down below, and which is the real plasma water, which is distilled and clean. That's what I thought. But I still have really fine dust in it. A plastic gallon of distilled water container, which I have many of them. So as I empty it, I fill it up with the GANs back in it. So it's part of a gallon which I shaked, and then it was muddy and it said on it, it's the middle CuO2. That's what was really shocked me. GAN is supposed to be CuO2, but which I have rested over the years, which I don't know the account of it. I don't know. I have no idea what they were sitting next to. Yeah, I'm sorry. Maybe I've.
Okay, well, that's good, Alper. Thank you very much.
Thank you so much, Rick. Thank you for letting me. Thanks. Bye.
What I could add is when you treat steel or iron with chrome covering, normally you treat the iron beforehand with some copper, and then for the chromium to clad on the iron, you use this copper. In zinc plating, the zinc is only used on the steel. You don't have to use any other intermediary material, because there's
Yeah.
forms an amalgamated conjunction between iron and zinc, and it's an intermediate coating.
Well, that's a good point, John. And perhaps when the chromium plating comes off, next will be copper. So it would be copper and copper interaction. Maybe that would produce the copper oxide. And then eventually when the copper wears through, you'd have the iron and you'd have the CH3 interaction. So you would have an interesting progression there, I think, over time. We'll have Alper have to report in on that little experiment every week, and we'll see the changes that go on.
It all depends on what process they use to do the chromium cladding on the iron.
Yeah. Sometimes nickel is involved as well, so you can have nickel plating instead of chromium.
Yeah, normally the nickel is done as a last job to give it more luster.
More shine, yeah.
Exactly.
And of course, if you use tools that have those kinds of nickel or chromium platings or other types of platings, and eventually you can develop allergies to those elements, as I have.
And the nickel also is used because it's, as far as I can remember, it's harder than the chromium. So it gives it a harder surface to resist knocks or whatever. That's why it's also used on the bumpers of the old cars and what have you.
Alrighty, probably enough about that for now. Thank you, everybody. Let's move on to the next topic. It's interesting. I'm seeing that plasma ball in the background here, and the way that where's my finger here? That sort of red circle around the ball. It doesn't look like that at all here. Live, to me, the ball is more or less orangey, sort of red color. It doesn't have the yellow tinge to it that I see in the video at all, and there's no line around it. I'm just going to move it a little closer and see if that reddish line stays with it, or does it? Wow, it's ever strange. It looks so much different to me right here than what it looks like in the video. Especially
sort of interacts with the lighting you got in the room.
Yes, it sure does. Look at that. It's the background makes all the difference to the video camera, apparently. But to me, it looks pretty much the same. It's the same color wherever I put it. It's all orange, orange, orange. But there, to you, it's virtually disappears in that white screen. And yet, to me, it looks completely orange, just the way it looks all the time. So the camera is picking up a totally different range of signal from the light of this than what my eyes are. Interesting. I haven't noticed that before with other plasma balls, really. Maybe it's just that particular color happens to do that. All righty. Anyways, anybody else have something they would like to bring up here? Topic of interest or a new project, perhaps?
Yeah, there in the chat, Alper mentions plutonium. It's chromium, not plutonium.
Okay. Okay, I don't see any questions in the in that chat or the other chat. Let me check chat number 3. We're good there. Chat number 4. Good there. Q&A. Good there. Okay.
I asking, what is that? Is that sort of a mountain with your globe on top, isn't it?
Oh, that. Okay, that's what he's referring to. Yeah, it's just it just makes it look like it's supposed to look like a volcano is the idea. So it's when I go to thrift stores and places like that, sometimes I pick up plasma. I always get plasma balls if I see them available, basically, because I'm like the home for wayward plasma balls, especially oddball ones like that. That's an old school one that's probably pretty old, and it's really heavy and it's got a good power supply and so on. So it's always a potential candidate for a good power supply. When they jump off the desk and break themselves on the floor, for example, then you can use the power supply to do other experiments with. I've had several commit hara-kiri by jumping off my desk at the wrong time, smashing themselves on the floor. You gotta be careful of that and try to herd them up at the right time so they don't do that. Okay, what else can we bring up here? You see.
You haven't any reactors in your background. Ah, yes, there are a couple of them. Yeah, they are small.
No, I've got some set up, but they're not. All the motors have seized. I've actually got a bunch of motors coming and a new reactor and so on. It's in the mail. I got a notice for it a couple of days ago, and so I'll be putting that together this week to get my reactors running again here. And I've got another project with the lathe and a ball on that, and it's just not set up and ready to go right now, but there's another project in the background, and I've got the back lab area. I've got several boxes set up ready to start nano coating processes, or not, both nano coating and GANs. Actually, I've got nano coated plates ready to go and whatnot. So things are happening in the background here. I've been pretty busy in other stuff too, so it's hectic trying to get everything done, and these Tuesdays/Wednesdays seem to come by so fast. It seems to be like all these Seekers workshop on Thursday, and then bing, 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 and suddenly it's Tuesday, Wednesday, whatever you call it, time for the plasma group again. So Jay says, Rick, have you ever tried to make a Jacob's ladder? The 2 copper pipes in the background. Oh yeah, I see over there. These copper pipes look like the Jacob's ladder. Actually, I have made Jacob's ladder. I made one with, I had young students at one point doing science experiments, and that's one of the ones we did was use, I think we used microwave oven transformer and made a real dangerous kind of Jacob's ladder thing that we had to put a protective polycarbonate tube around it, actually, to make sure no one touched it and get electrocuted. So, yeah, it can be fun. It's basically just if you were to imagine those two copper tubes in the background there that Jay was talking about, and if you had high voltage between them, you would get an arc that starts at the bottom and arcs between the two tubes and goes all the way up to the top and then flares out at the top and then starts back at the bottom again. So it goes as the spark flame moves up the pipes and sort of jumps off the top. So yeah, that's called the Jacob's ladder for anybody who's interested in that. It's kind of an interesting phenomena. And the reason they spark or arc is you have a high voltage between the two rods here at the bottom, and it's enough to overcome the resistance of the air, and so a spark jumps in between and ionizes the air, and once that air is ionized it becomes more conductive, so it actually conducts easier, and because of the heat and the lighter components it tends to rise up on these pipes and will jump the larger gap because the air is ionized and already conducting the electricity all the way very easily. So it tends to rise up to the top, sort of jumps off the top, and then it starts again at the bottom. It'll jump at the bottom first because the contacts are closest together. And once that air is ionized with that spark again, it goes right up again and just repeats that. Yes, it is like a tear in space-time, you might say, Jay. In fact, every spark is a tear in space-time in a way. And I think that's what Nikola Tesla recognized many years ago when he investigated lightning. He spent so much time with lightning. He became totally familiar with lightning, and he could predict storms up to 1,000 miles away with his sensitive antenna type gear that was able to sense electromagnetic effects at a distance of up to 1,000 miles, in fact even more. He could sense things on the other side of the planet with his system. But specifically listen to lightning bolts because they were very special to him, and he even named the lightning bolts that he heard through his apparatus. And he would call them special Greek and Roman names from the gods and goddesses of the ancient times, because he thought that each lightning bolt had its own personality, had its own essence, and he would actually name his favorite ones. So it's interesting how important that is. And the thing about sparks and lightning is it's a very wide band emission that comes out, and it can affect virtually all ranges of the radio frequencies. That's why you hear static in radios. It's what they try to eliminate, the static from the atmosphere. It's mostly lightning bolts going off. I think there's something like it's in the thousands of lightning bolts a second that are going off around the world at any particular time. So there's lots of static from all that, from that potential being unleashed. And if you look at it, the lightning bolt is one of the only forms of what scientists would call plasma that we have on this planet that is not created by man in some way. Other than fire, you could consider fire as a form of plasma, what scientists consider the so-called fourth form of matter, plasma. We have solids, liquids, gases, and plasma are the four categories that scientists would say. And that plasma can be in the form of fire, can be in the form of lightning bolt or other phenomena like that, which is common out in space, but not so common on Earth. And but we talk about plasma in a different way with the Keshe Foundation. It's much more inclusive definition, and you would say, we could say that the atom, you know, the parts that make up atoms are actually plasma inside the atom. We call it the plasma of the proton, the plasma of the neutron, the plasma of many things. You could have a plasma field from different reactors, different interactions, from ganses. We have plasma water that's created from the GANs creation, and all kinds of ways that
Rick.
we use plasma. Yes.
Hi, Rick. This is Estela. Actually, we are defining a new way of interaction with our environment. It's through plasma field. We are
Right.
plasma. And it was an interesting exercise that looking at the ball that you're having in the background. And the first thing it came to me is, you know, our own body in the interaction, you probably through your perception, you see different, you know, feels, you know, in your own interaction. But when we are sharing now through a machine, the perception changed because it's a different feel interaction, you know?
Mm-hmm. Yeah, it's interesting.
So,
if I were to hook up this device, for example, and hook it to my computer through the sound system, then it would hear that plasma ball and perceive it in a much different way than we would perceive it. You'd hear all these different frequencies and sounds, and it's quite intense. Its fields are perceivable by this device up to many meters away. And you know, there's other devices that have other ways of perceiving as well. Each one is different, a different range.
And also your body depends on your gangs, your own body gangs is how it performs too, right? So that's why everybody has a unique, different interaction. It's not the same perception that we kind of share one, but I truly believe perception of what you're sharing is different for each individual. Because even I know people, for example, they are colorblind. Maybe you see more reds because you have different kind of receptors in your eyes. You know, your gangs may work in a different way. So,
well, that's right.
Yeah, what I was trying to say is through plasma, now we start to understand the environment and how we interact in the environment, and it's a completely different game. You know.
Yes, that's right.
That's how I see it. It's not only the plasma that we do in learning through Keshe. It's like everything is plasma.
Well, that's right. So one can have different perceptions or different levels of perception, let's say. And like Mr. Keshe,
and when you
can have
and when you improve, you elevate your soul, the perception change.
Yeah.
Because your feel change, you know. So, and this is another thing I want to. We live until Keshe. Until we start to learn about the soul. We live in separation. Once we understood about the soul and the plasma and interaction of the fields, we start to understand that, oh my God, I'm not alone. I'm consistently interacting with everything. So we are slowly changing to the perception of like, I am part of everything. I am Estella, but also at the same time, I'm part of you. I'm part of the team is there. We are all in the same field because we are being one.
Yes.
As a field interaction.
Essentially, yes. It gets a little
as a
tricky.
field interaction. No, I know, but it's the field interaction what makes yourself in that moment of it's a moment in time, you know, that we are interacting of the fields and we are, you know, one in one field.
So when you say
That's
we, what do you mean by we in that instance then? Is there only, if there's only one, then who is the we? We indicate
all the people in the
myself and someone else. But if I identify with the self that is connected with everything, then that is like one being. So therefore, there is no other than that being. In other words, it becomes another loneliness in a way, because you might say from God's point of view, there's only God, therefore there is no other. There is no Estella plus the connection to everyone. There's just the
no. I was talking only about the fields. The fields. In terms of the fields, you're one because you are interacting. I wasn't talking a being of a person. Well, I'm talking about plasma.
Yes,
because you're interacting.
But who is the you? You're saying that we are plasma, so we're not physicality. In other words, it's the identification of you. Who do we mean by I when we say I am, you know, doing something, or I am here, or I am a field interaction, or
well, because it's this, you have a matter body, but also you're interacting at the plasma level and you're interacting in this physical with the environment, and you have your soul.
Yes.
So you cannot limit yourself of the interaction at one level, because you know your plasma and you have gangs in your body. Okay, so what I'm trying to say is to be...
Go ahead, sorry.
What I was trying to say is, like, you don't see yourself only as your matter state that we're here, we share in a conversation, interact in our plasma fields. It's like you are in a different position at the same time. That's what, at this moment. When I hang out the communication, I'm not interacting directly.
Yeah, it gets into this sort of fine line as do we have a soul or do we have a body?
We have it all.
The body, or are we a body with a soul?
I think we are.
Are we a human having a spiritual experience, or a spiritual being having a human experience?
I believe on that one, because your intention was coming to the matter state at this position to have this particular experience. Whereas the earth and the sun create this matter, and you, with intention, you decide to come here. That's what I believe.
Yeah, so
that's why I was saying, when we start to understand the plasma at the bigger picture, we're consistently interacting at a plasma level, and that's why it's so important to be in peace and to have good intentions and to, you know, interact with others at the good, you know, soul level and at the matter level.
Because the effects can be deeper and more permanent, perhaps, or more affecting.
Yeah, because you honor, you love the others just with your attitude and your respect and your interaction. You don't need to say it like, Rick, I love you. I'm just being, you know, respectful and interacting in the proper way. We are, you know, interacting on a good level at the plasma with good field strength. That's how, you know, elevating ourselves.
Mm-hmm. A good input. Thank you, Stella. Anything else on that you'd like to bring up?
So, no, it just was about the plasma field and thinking and experiencing at the different level. Because I also, for example, I look at my dogs. They love to, you know, consistently looking to go to the earth or to the plants, and I look at them. Oh, they're interacting with the tree, or they're, you know, they sit under the tree or with the grass, and everything is in, you know, you start to look at things in a completely different way, you know, and it's kind of cool. That's just want to say that.
Yeah, it's kind of cool.
Thank you, guys.
It's kind of cool. Alrighty. Any other input on anything that anyone would like to input about? Input. We need input. Need input. Now's your big opportunity. We've got 20 people here or something.
Well, this is Marshak. I haven't waited my whole life, but you know, I'll try to talk about something that's immediate that happened. So, it's. Does anybody have any experience with the plasma batteries? I'm doing some experiments. So I just wanted to see what people have, what kind of experience people have. I have some, and I can share that. Yeah, I can share my camera, but it's kind of disorganized. But anyway, I can talk about it. But if anybody has any experience, I'd love to hear about it.
Okay, next topic, plasma batteries. Anybody would like to add something about plasma batteries? So that is specifically plasma battery, not plasma capacitor you're talking about too, right?
Yes, specifically plasma battery.
Okay, no input. Well, do you want to show a picture, what you have there?
Let me do something. Let me put my camera on a stand, but I can start talking about it while I do that. And so the basic idea that I'm exploring is create variable voltage plasma batteries. And essentially, the basic idea is to create a plasma potential gradient.
Well, it's always good to explain further. Sure.
Yeah, maybe before I even show with my camera, maybe I should draw or talk about it a little more. So we know that we can. I'll talk a little bit about the basics of plasma battery, which is essentially you have.
Want a whiteboard? Should I start a whiteboard for you, or do you want?
Yeah, maybe that's a good idea. Maybe that's a good idea. Maybe I should log in from my computer, and then I can use a pen with my computer. Hang on, let me do that.
Sure.
Log in from my computer as to the same meeting, and then perhaps do it from there. Okay, hang on. But I can talk as I'm doing that. So basically, the plasma batteries that we make is that we have a coil. We can have a coil or a nano-coated wire in the middle. And then we put some sort of aluminum foil or other material. And before that, of course, we put the paper with GaNs, just like we do in the capacitors. And then what we do, we put aluminum foil is one common one, but it can be other things as well. Okay, and so and then we have a coil on top of it, and we can get different kind of voltages depending on the number of turns from the top coil. So anyway, let me draw this. Okay, oh, I have to.
Okay, MOSFET's just getting set up with computer number 2 here.
I was turning off my computer microphone and so forth. But anyway, so let me do the whiteboard from my computer, and then I can draw it.
Okay, we see that.
Okay, so let's draw what we just talked about. So this is the middle wire, let's call it that. Then above that, let's say we put some paper. We roll some paper around it. Or essentially, we have to put some GaNs here. It doesn't have to be paper. And after that, we have, let's pick a different color. So then we have, let's say, something like aluminum on top of it. And then we, again, put some coil at the top. Usually, I'll just draw dots. It's a coil. That's the plasma battery, and this is we get our positive from here, and the entry, that's the exit, and that's the entry, right? Now, so this is our basic plasma battery. So one of the things we often do is we can create feedback so that it replenishes itself. It's so much like Alex battery and other things. And so this is the basic structure. Now, if we measure using a multimeter voltages across this coil, we see that as we go from here in this direction, the voltage increases. So my experiment has been to create plasma batteries with different voltages that I can slide something around it so that I can tap into, create different voltages by just sliding things around. So one of the things I have come across, and there has been I made some changes to this basic design. So instead of wire in the middle, you can put another coil, and Mr. Keshe talks about that like that. So this is one approach. I have also tried a nano-coated tube. It's not that you remove the copper, but the inside and the outside surface of this tube is nano-coated. It's a very thin tube in the middle. So so I put this coil instead of the wire. So you have a hollow middle. This structure is similar to the one we are talking about these days, is to have a hollow middle where the high strength field is. Now, instead of a hollow middle, if we have a copper wire, we have a copper middle. So the copper middle doesn't allow us the liberty of an empty space. So that's the reason. And when I switch the wire with the coil, I read higher potential gradient increase as I slide. So this is one difference I've noticed. So this is only the middle wire replaced with a very thin coil. Now, I also tried, first I tried the other combination. Instead of the wire, put a tube in the inside and the tube on the outside, which is really easy to make actually. And I wasn't getting any reading, but both were nano-coated, and I was kind of puzzled. Why is this not working? It should be working better. So I did some tests. So I tried coating them with fire. It was melting and like separating. So I had some difficulty with that. But compared to the thicker wire, my electrical reading, I'm sure the plasma is flowing, but the electrical reading with a multimeter was less. And that was very puzzling. At first, because you have thick wire, which has less number of turns, but you're getting higher voltage. But in reality, as you put more turns, it should go up actually quicker in the thinner case, because it's the same distance, you have much more turns. So anyway, that was puzzling. So one of the things that I tried at that point is that maybe I have to think a little bit, because if we think in terms of current flow in a normal copper wire, for example, without any plasma coating, the current flows because of what is known as, in engineering, the skin effect. It is actually hugging the surface, not inside the copper, which is where the electron is free to vibrate. So as I reduce the wire size, the surface area is reducing. So the amount of available electron is diminishing. So this is one thing that's fairly obvious, and that's why we have less current carrying capacity in a thin wire compared to a thick wire. We use much thicker pipe or something like that for like creating when thunderstorm hits, so that it gets grounded. So it can carry a lot more, it has more electron vibration as we send electricity through it. So now, there is a clear indication that when we reduce the size of wire, although plasma may be flowing, but the electrical reading is going down, because the available number of vibrating electrons is reducing. So taking that idea to the tube, now in case of tube, you don't have separate wire. You do have a surface of the copper, and above that we have electrons, surface, nano-coated surface. So essentially the wire is one atom thick. And so the reading, I wasn't getting any change at all in the electrical reading side. For example, there is another test I did. If on a coil, if you move your probe of the, what do you call it, the multimeter, you see spikes. And this you do when you nanocode, when you put your multimeter across during nanocoding to drain the excess plasma or make the plasma stronger. Now here, when I slide across the winding, I get a spike of voltage in the electrical sense. But on a tube, if I slide, I don't get anything. So, I mean, the available vibration from the electron is not, the meter cannot read. I mean, I don't have a very sophisticated or powerful, sensitive meter, so there was no reading. But it was consistent. What was consistent is that the thicker wires were creating more bigger spike than the thinner wire. So that was an interesting observation. So in a sense, you can extrapolate from these experiments that the tube won't do any electrical output, but it should be, plasmatically, it should be more powerful. So that is my current, I don't have any way to test it, but from this experiment, it is clear that I'm not getting any electrical reading, so I can't use a multimeter to say, okay, this is better. But plasmatically, the more winding, the better it should be in terms of the potential that you're creating. So that's where I am. So I just wanted to share my experience. I have some, hang on a second, I have this prayer. You have to fill in. Yeah, I can't talk. Call.
Okay, I'll fill in for a second here. While we have the whiteboard up, I wanted to annotate here. Let's see. So he was talking about, Mosfak was talking about having a coil in the inner wire part. And the way I understood it is he was saying that the more coils he had, the was actually the less power he was getting, the less voltage he was measuring on the outer coil from the inner coil, or when the inner coil had more turns, it was getting a less voltage on the outer one. Well, I'll see if we clarify that when he comes back. But it kind of makes sense because if your center pin or center coil that we see here, if that is essentially where the core of your reactor is, and that's where the energy from the outside will be picked up essentially, and the plasma will have its main direction from that center core. But if it has a series of coils, then what happens is if you have a large number of coils, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, say there's 10 coils here, and then say we put, I don't know, 100 coils. Oh, let me use a different, oops. Let me undo that.
It's not the same like Magrav, multiplication of gradient.
Okay, well, the thing I was going to show just in terms of, say, like a regular electrical kind of flow, if we had 10 coils there, and then we had, say we had 100 coils wrapped around that. So 100 here, and 10 of the other ones, let's say. And, you know, the other one, this blue one probably would be wrapped all the way around and so on. Let's just say that that had 100 and the other one had 10. So we have basically 10 to 1 ratio between the two sets of coils. So that becomes more, that's like a transformer circuit in electricity. And you would have, if you put in, say, 100 volts here, then that could, 100 volts in the blue, in 100 coils, then what would you get out with 10 coils? And what it is.
Yes, but transformer works on AC, not on DC.
Perhaps it's, Mr. Sander, perhaps it's like a continuous DC, but it's impulse, like a Tesla. Train.
If you make a coil and wrap it around a nail and put DC power into it, it'll still act as a magnetic field in the coil and create a magnetic field. And you can make and break that circuit, and you could have interrupted DC is basically the same as AC, and have a pulse DC will give a same coil effect. The idea is just being that, like, we should be looking at it plasmatically anyway, rather than the electron flow and the way transformers work. But basically, it's the same as a Tesla coil. If you look at a Tesla coil, and you've got, normally they're stacked up. So let's look at it that way. And say you had, instead of 100, you have 1,000 here. And instead of 10 on the bottom, you've only got one coil around the bottom, let's say, like that. Well, then you've got 1,000 to 1 ratio. And if you were to put, say, 100 volts in here, you would get 100,000 volts out of the other coil. So I just wanted to say that this is the way the voltage, as far as voltage goes, how you can step up the voltage through a Tesla coil or other type. It's basically a transformer arrangement, and there's all kinds of transformers. All the little wall wart boxes that we plug into the wall to power our various devices are simply a transformer. Some of them are AC, some of them are DC output, but they're AC transformers, like Sandra was saying, that plug into the AC alternating current coming out of most of our wall circuits. But in the case of the Tesla coil, you have a big amplification, and that creates fields from that Tesla coil that can extend out many feet. And you can generate sparks, of course. They're known for generating sparks, but you can also do other things with the Tesla coil, including create music just from the fields emitted from that top electrode. So once you get up around 200,000 or 300,000 volts, then you get in some really interesting effects as far as the fields go. But back to the original, thing of MOSFET here. I think that if he puts multiple coils in the middle, then it has the effect of putting multiple coils on a Tesla coil. And if you were to do that on this bottom red coil, let's say put in, say, 10 coils instead of 1, then that would only make this 10,000 volts instead of 100,000. And it wouldn't have anywhere near the effect that we're looking for. But it would have 10 times more amperage as well. So it might become more deadly to a human being that responds more to the amperage than to the voltage. So that's the way coils work. You can increase the voltage, but it becomes less amperage. You can increase the amperage, but it becomes less voltage, and ends up volts times amps equals watts, and you end up with the same at the end.
Rick, probably I should explain my experiments a little better. I think there is a little bit of lack of clarity because I went through fairly fast, actually. So
yeah.
Let me try to, let me erase this, and I'll slowly go over the experiments, because the experiments is kind of like quite, so let's see. Let me see. First, I tested sort of an inner coil, and you have inner coil. I won't draw the GANs part, just indicate that that's the GANs part. And GANs, and let's see. This is the GANs part. And this is the okay. This is the aluminum coil, foil part. Now, I did the experiment first with this kind of configuration, but the gauge of the wire were thicker, so I had less turns. And as I was reading the voltages, so this is your ground, so the entry point, and this is, so I was getting voltages at different locations. So I was getting fairly, millivolts, even beyond 1 volt from, it was fairly long, so I was getting more than 1 volt reading towards the end. So it diminished as I went further towards the ground, or the entry point. So this was the first experiment. The second experiment is identical, but the gauge of the wire was finer in both the inner coil and the outer coil. And I was getting less increase, although I had more turns. I expected it to give me higher voltage with the same length, but since the number of turns were higher, I was expecting higher voltage. But instead, there was clearly an increase as I moved from left to right, but the voltage increase was not that high. So this was the 2 measurements I did. And the next one, let me draw another picture, which is the same, but instead of the coil, it was a tube. And I did not get any reading. Now, the interesting part was I mixed the two. So instead of inner coil, outer coil, inner tube, outer tube, so there was no reading in this second case. I was not getting any electrical reading. Although everything was nano-coated, the rest of the setup was identical.
Hello, are you still there? Did we lose contact with Moshfaq? Hello, Moshfaq. Come in, Moshfaq. Can't hear you right now, Moshfaq.
Go ahead,
John. Yeah.
One thing that could be changed is use a very thin capillary copper pipe and make windings in the inner core.
Oh, we just lost Moshfaq's thing. I'll put up a new whiteboard here, I think. Oops.
Can you hear me now?
Yes, and we lost your whiteboard. I was going to put another one.
Okay, it's okay. It shouldn't take too long to do it. I'll just. Okay, I'm going to start the whiteboard again. The third experiment, what I did is instead of the inner coil, I put the tube inside. And oops. Okay. Anyway, sorry about that. No, this wasn't. Sorry. This. Okay. This was the. Okay. Why is this getting? I'm getting disconnected. Can you hear me?
Yep, no problem.
But my laptop is okay. So yeah, it's back. It took a little bit. There was a delay. So instead of the inner coil, I replaced it with a tube. Now, when I put the tube back in, although in the two tubes cases I was not getting any reading, but I was getting better results here than the two coils. So that was the most fascinating. So the inner tube is working as if like a coil, and it, in fact, better, but the two tubes did not work, but this worked well. And I was getting slightly better voltages on my readings that I was doing in these areas. So, so that was the puzzling part for me. Later on, I kind of figured out what's going on, but at that time, I kind of stopped doing it because it was very anomalous from my point of view at that time, because the coil worked very well, but the two tubes did not work well, but the combination of inner tube and the outer coil works very well, in fact, better. So my basic feeling after this was that I was reading the electrical current, which was happening at the surface of the copper, but not the plasma, because I don't have any way to read plasma of other plasmas. So the plasma is happening, but I just don't have a way to read it in case of the tube, because it's just like before, based on my previous experiment, with number of turns increasing, I have diminishing current. So in case of the tube, I have essentially one atom thick turns. And there is not enough electron vibration to get any reading out of it. So this was my conclusion out of all of these. And I will do some further testing, but the plasma is there, but the electrical reading is absent. So if we look at from the electrical point of view, there is nothing happening. But actually is, because when I replaced the coil with a tube, it did work, in fact, better. So something is going on, but I don't have an ability to read it. So this is really my conclusion out of this set of tests that I did. So I just wanted to share this idea because I put some effort into it, and there is, of course, they will be used in some other, I will use this for some other purpose to create the voltage gradient that I need, or the potential gradient in plasma. And not in the electrical. I'm not really interested in the electrical range, actually. That was just to make the measurements. Now, if anybody has any idea of how to do the measurement, I would be glad to hear about it. But right now, I don't have a mechanism to do the measurement, but I can guess that it is there because the tube is working. Only I have to have a sufficient amount of electrons available on the surface of the wire to create the electrical signals. And so that's what's absent. That's how I feel about it, because the tests indicate that the configurations were right, but the the number of turns available is diminishing to the level of nanoscale, and you don't have enough electrons at that scale to make enough current or voltage to make any reading. And this can be also proven by also not only just the little voltage that I get by point measurement, but if you slide the multimeter probe across the coil, you get spikes. In case of the tube, you don't get any spikes. But in case of the coil, you get the spike, whether there is an inside coil or an inside tube. So the inside tube is working. But when I have two tubes, I don't have a way to read out from the outside using a multimeter. So that's the basic point I'm trying to convey. Any thoughts or any suggestion how I may want to proceed further would be welcome. And so anyway, so that's what I wanted to relate to. And if you have any question or clarification, further clarification, I can go into more detail of any of these.
First, I'd like to ask your inner tube that you made. How did you you fire nano coated it? Did it have? Did you test?
I tried both, and both worked.
Okay.
And nano, I mean the tubes. Then since it's a very smooth surface, it's difficult to keep it the nano layer when you fire coat it. So since both work, I will probably go to the caustic because it's more sturdy. And the fire nano coating was if you touch one time, it kind of comes off. It's very smooth surface, so it doesn't stay very well. Even worse than the normal fire coating of wire, much worse.
Right, and it could be quite thin as well at times. It may not be the same insulator properties as a good nano coating, so it might conduct differently. But it's interesting. So what came to mind with me is perhaps there's another way to look at it, which is maybe by putting some energy into the system to create that electron flow that you were mentioning, it would produce something in the center of this system. In other words, you've got that nice hole in the middle there, basically, that empty space that you've created with this tube arrangement in the center. Perhaps by certain kinds of jolting, as Alper mentioned in the chat, by jolting the circuit with maybe a pulsed DC of a certain frequency in the outer coil, might be able to induce a special plasma state in the center of this device. And the other thing that came to mind is you could possibly close the ends of that tube and create a vacuum in that space. And then that might create even a more special plasma chamber inside there that could be worked with. But that's kind of abstract and some of the thoughts that I had. But if we look at some advice from Peter, he mentions zinc oxide plus electrolytic spacer plus iron equals power for hundreds of years. I think that's one of the formulas for these, what do they call them, mineral batteries, or there's batteries that actually last for, there's some that are 100 years old or more, and they're still going. Okay, well, let's get back to Mashfaq's.
Is that what batteries are you talking about? I'm not aware of these batteries. I'm not
I think
much into free energy, so I don't know too much about this world.
I could go a little bit into it.
Yeah, go ahead.
Okay, well, there's multiple names for it, also called Faber battery. Really, when you look at it on the scientific level, it does utilize plasma sciences, because the zinc oxide and the iron, it'd probably be better if it was iron oxide. Using the basic techniques that even the Foundation uses, will utilize the highest quality of it, which really kind of makes it plasma technology. So really, it'd be a plasma battery if you do it right.
But you're talking about one that you sort of make your own battery by a paste, a kind of a paste. You put in a center electrode and you pack this paste around it, sort of thing. Is that what you were talking about?
Well,
And then it hardens. So.
The electrolytic spacer would be the only thing that you could probably make it a paste if you wanted to, but even that could be hard structure. It's even just the zinc, it rendered down from its Gantt state in the fluid, and you dry it out, and you get the actual mass, the powdered state. So you'd use that.
So what's the name of the battery you said?
It's called multiple things. Forever battery. It's also a type of plasma battery. There's numerous names for it. I can't remember the actual man who brought me onto it. Actually, Michel Grenier was actually the one who pointed me out onto that one.
I see. One of the things I'm trying to achieve is not really electrical potential. I mean, although that's one course of action, of course, if you want to use these as normal batteries. But I'm trying to achieve like just plasma height, plasma gradient. And that's all I'm interested in. And I would be very curious if anybody has any experimentation or even thoughts about measuring this plasma gradient that's being created, although I know it's being created, but I cannot measure it.
One way is by seeing if it's putting out any fields, and there are ways like you can use an iPhone and there's magnetic field detectors and electric field detectors, and there's
that's a good idea. Good idea. I didn't think about it, but it's a really good thought. I mean, I'll try it.
I got a few suggestions to you.
One more.
All right, go ahead.
Just before you begin there, Peter, one more would be the crystal radio circuit. You could make this battery essentially as part of a crystal radio circuit, and you could actually tune it or tune the circuit through this probing of the wires and that kind of thing. And you might be able to, rig up kind of a resonant response from it, so it becomes part of a circuitry, and then you could probe it in different ways and sort of listen as a response, and tell exactly what's going on in a auditory way, what kind of fields or what kind of waves are being given off. Look at it with an oscilloscope and that kind of thing as well. Go ahead, Peter.
I agree with what you said there, Rick, with the oscilloscope and everything, absolutely. So I put the link in the chat for trifield.com. They do a really good meter that does magnetic, electromagnetic, and actually RF microwave radiation. And it goes down to the third decimal point, so it's very, very, you can actually like trace field geometry with it. And it's one of
I agree with that. That's one that I've been lusting for a while. I think they're about around the $300 mark, and very nice instrument, quite often used by labs around the world, and also just for Ghostbusters and people like that like to detect fields. So it's a lot of fun field detecting. You can detect fields anywhere,
One of the other things is you can get a non-contact voltmeter, so you can actually use it to go around the wire without actually contact, and that can get you some at least some ratings on it as well. But personally, ever since I bought the Tri-Field, I've been having a lot of fun and hard data. Especially the RF microwave detector on it. It can detect the 5G and everything, and man, it's quite interesting, the fields and the electromagnetic fields and the dirty electricity and all that, and how it reacts with things like glass and resonance materials and things like that, which can affect your plasma making abilities because it imprints negative intention, right?
Very interesting. Okay, here are my thoughts. And I have some experience when this was a long time ago when I was first doing some of these things. I made something like Ali did, which is essentially maggraph, but with very fine gauge wire. It was back in 2016, early 2016, which is where you can, there were essentially, how many? 9 maggraph coil, one, this kind of configuration of 3. And in the center, there were many, like a stack of 6, like this. So I could feel the fields. I know how to create these kind of situations and feel the fields. And they were all, GANs coded and so forth. So it was creating a field flow this way, much like what John is doing right now. So one of the thoughts, which is to, since I need to see whether this makes a difference, so one could do this. This is the entry point, and this is our exit. So I can connect these to a reactor, be it a coil type of reactor or a ball type of reactor, either way. And if I see a change in the field here, based on the, let's say, this point reading versus this point reading, I know, which I can feel with my hands, like this case, I could feel the changes in the field with my hand. So this is something I can do to see whether plasmatically it's making a difference. So this is what I am thinking right now, but we'll see how after the experiment.
Definitely comes to mind. And what also came to mind along with that is that you may need to make your device larger in order to get the effect of the fields or feel the fields more. For example, you could, instead of having one device like this, you could put 10 of them in tandem, either in series or parallel, however way, pack them together, or certain configurations and so on, or build the device larger, use a larger, bigger wire, and make it huge, make it a foot tall or something, like with big pieces of pipe, or some way to amplify it so that the fields are easier, the plasma fields are easier to detect.
I can detect an American influence in a Canadian as well. Bigger things. No, I'm just kidding.
Yes, I know. It just came to mind too. I'm thinking bigger. When at the same time, I'm thinking, well, what if you made it really tiny micro, and then you can still feel the fields from a micro thing. I mean, you could be looking through a microscope at a detailed little tiny wee copper coil, and maybe it's possible, that you feel the fields from that tiny wee little coil as much or more, perhaps, than a giant one. So it's in that realm of plasma. It's on a different scale. It's scalar in that size doesn't matter as much in a way, it seems. Even a very tiny wee device can have quite a strong effect. A small vial of GANs or something could have a large effect, for example.
Can I jump in?
So for example, let me just say, I mean, the coil I made with the fine wire were like 250 turns. So this one was 250 turns. So it was fairly big in that sense, not in the American sense. But the tube is even furthermore, because if you think about it as a nanoscale as being one wire, then it's actually a lot of turns. But that's my thinking. But my experiment is to just go through a sequence. Sure, go ahead.
Sorry to interrupt. I have
no problem.
A lot of time. Hi everyone. Moshfak, you done CO2, yes?
Yes.
And which salts contents? 1%, 0.5%, 2%, 1.5%, 2.5%, or 3%, or 20%?
I have tested from 3 to 30.
Okay. There is a difference between them, yes?
Yes, and different salts have different things. Yes, I
Okay.
have done those. Yeah.
You went to the nano coating. You know how many layers you have?
Well, this is not. I don't have a microscope, but from what I hear, it's like 30,000 to 50, somewhere in that range.
What about you make a ratio from 5,000 and the other one is 50,000? What you will have?
You're talking about nano layers?
Nano layers, yes.
I don't know, because I don't have any way of knowing, as it's building up, to what point it has built up.
Okay.
So I don't have a way of quantifying the number of layers, but go ahead.
Okay. We all doing our nano coating. We put it 24 hours and bathing 24 hours or 10 weeks or so 1 month and leave them. Why? Because nano layers is building. When you build nano layers, you will have a very wide spectrum of fields. So the layering, more spectrum of fields. But if you have only 3,000 or 4,000, how are you gonna nano coat 3,000 or 4,000? Now you have to think about time. You understand?
Yeah, I understand what you're saying.
You don't need to nano coat it 1 day. Maybe you need to nano coat 1 day, 1 hour. So in this way, now you will have 5,000 layer, and this 5,000 layer, it get only 1 or 2, 3 kind of field. And you have 50,000, and this 50,000 will give you, let's say, 100 kind of field, wide spectrum. So you have a ratio. And Mr. Cash said plasma work only in ratio. And there is a difference between caustic nano coating and fire nano coating and Coca-Cola bottle nano coating. You need to consider that in your work, and really, especially in the batteries or especially in the spaceship. I think less nano coating, nano layering in a special way, in special spots in the aircraft. It will give you more effect. It is the same kind of salt. You are doing CO2 with different kind of salt and different kind of what do you call it, percent. And understand your body is contained of salts and different kind of salts and different kind of percentage of salts. Now we are going deeper. It's not like one human body. There is thousands of fields in you, and if you get it and you only understanding, so you don't need to really check out the plasma field. You don't need it. You put nano coating wire in caustic, let's say in 1 hour. You make the same nano coating wire in 2 hours in the same mind of temperature and same kind of environment. But you see, 1 hour it will give you, let's say, for example, 1,000. 2 hours it will give you 3,000. 3 hours will give you. You see, like this. And then you will have your measurement. It's unique to consider that. This is in the teaching of Mr. Cash. And funny thing that yesterday I came through it without noticing. It's come just like this. And now when you are speaking about the battery and the layering, and it's not working, and then the other side is working, I'm thinking about that. I'm thinking on this thing, and jump in the salt contains and the percentage. And I think it's worth to consider that. Thank you, guys.
Thank you very much, Jalal, because this is very valuable, and I think your thoughts about looking into nano coating, and even the part that I haven't really explored, but it would be good to hear about other people's experience, and this is the plasma nano coating, because I hear it takes a long time, but I have some thoughts about speeding up the process, and part of the application of this battery is to that. You create a gradient so that the flow increases, and your plasma nano coating can be faster. So this is another line of thinking, and you mentioned about plasma nano coating. Also, this is, and you can control a lot more here because you have a control over the gradient. So the flow that's being created in the nano layer, and to what extent you create the flow also dictates the number of layers that gets formed. So some of these thoughts are kind of in my periphery, but Jalal, thank you for reminding me, because some of these actually are relevant in what I'm doing right now actually as well. So thank you very much. So any thoughts on the plasma nano coating part? Anybody, any experience to share?
Well, one thing that comes to mind is the battery, as you've outlined it here, might sort of grow over time if you just allow it to mature, or perhaps there's a certain environment that would be conducive to it, so that the nano starts to work with the ganses, and the ganses work with the matter level, and with the aluminum, and the aluminum works with the nano again, and so on. They have to sort of grow into each other, and it may take days, weeks, or even months for that process to occur, to create the plasma pathways inside, let's say, because there might be like places where there's matter level stuff where there shouldn't be, or air pockets that shouldn't be there where it should be essentially a vacuum created through the nano layering process. And then if you start out with maybe 5,000 layers, and maybe after a couple of weeks it's 10, 20, 30, 50,000 layers, and you've created more plasma pathways that way. If you consider each layer is a possible plasma pathway, then it seems like, on the surface, so to speak, that the more nano layers, the better. But it's not always the case. Sometimes a thin nano layer can be more effective than multiple nano layers, depending on exactly the geometry of how it's formed, and other materials that are embedded in it, and all that kind of process.
Very important point, Rick, because what you said is actually, let me draw this. Actually, this ball actually is a good example. You can think of the inner nanotube, the tube, and the outer tube. Now, you said to wait for a while. Actually, this is maybe very important, because this area, let me color it. This area is an enclosed area by nanomaterial. So it's kind of like our body. So in order for the field to build up here, and we have here GANS material as well. So the fields of various strengths are building up, and the outer tube, there is plasma flow that's rotating as well. So the field buildup will take a bit of time, which I never thought about. Actually, this is a very interesting point, because this is like putting a little empty ball in the middle. That's the main reason you went to the tube or the coil approach instead of a wire approach, is to have the field in the middle. So what Rick, you just pointed out, I forgot about it conveniently, but it's actually a very important point, to let the field build up and then do something with it. I mean, whether I get electrical reading or not is irrelevant, but this very point is very relevant in the sense of building up the field and allowing it to rest and I just stick it in and measure it. You know, that's a patient approach might be, as Rick is pointing out, might give a much better result. Thank you very much.
Yeah, there's different ways to look at that. You could process. I've run into the idea recently. It keeps popping into my mind enough that I actually bought a microwave recently. I want to try some. I have been trying some experiments with the microwave, and I'm thinking I had this vision or idea that you would take a plasma battery similar to this and basically pop it in the microwave to charge it up, you could say, or to be the ignition key to start the plasma battery. And then you take it out, you power your home with it for the next 2 or 3 months or whatever, days, months, whatever, hours. And then when it runs out, you pop it back in the microwave for a little shot, and it rejuvenates it because it restarts the ignition process. Because microwaves are quite powerful. I put a little piece of copper in the microwave the other day just to see what would happen. It was a square piece of thin aluminum sheet, about maybe an inch or two long and about a ½ inch wide. And it was very interesting. The edges, the 4 corners of this rectangle piece of copper went crazy with sparks. Like if I was to, I'll just show you here briefly. If you look at it like this, there was big time sparks coming out of each corner of this piece within just a couple of seconds, maybe 3 or 4 or 5 seconds into microwaving. I only did 5 or 10 seconds at a time because I didn't know what was going to happen. And it put out intense, not just sparks, but it was actually enough. I had a piece inside of a lab flask, actually, like this. And I had a tiny bit of water in there as well, some GANS water I was testing out. And within a few seconds, this thing actually melted into the lab glass and etched into the wall of the lab glass where this piece of copper was. Basically, it turned into a plasma at the 4 corners, but especially where it was touching on the flask, it just melted right into it and put a permanent mark in it. And not only marked it, but it made a mark that kind of looked like this. It had little cracks all the way across the, I think there was 2 sort of arc marks. And this all happened just within maybe 2 or 3 seconds at the most. Just as soon as it flashed up, I turned off the microwave. And it just etched into it and cracked that lab glass that can normally be heated red hot, and basically you can put it into water and it won't even crack the glass. This is really the toughest glass you can get, basically. And it just cracked it and etched it. And I just went, whoa, there's a lot of energy coming from that. So I'm thinking, how can I take advantage of that and create a tiny little seed plasma in the center of this battery, perhaps, and get the flow going, just to sort of start it somehow, jumpstart the battery, jumpstart the plasma battery. And And then to rejuvenate it, you just, like I say, everyone's got a microwave, and you have this little battery pack you keep with you for powering all this stuff you need, all your devices, and maybe it would even, you stick it in your car and it powers your car. I don't know, could be. But some little battery pack that you put in the microwave, hit it 10 seconds, maybe a minute, I don't know. And it starts it up, and away you go. And then you've started that plasma process. And Mr. Keshe talks about the ignition key, for example, and maybe there's a way with, you know, our modern technologies that we can use them as an ignition key to take our plasma battery technology to another level. Or it could blow out your microwave and cause a fire. Don't blame me. Please be careful playing with microwaves. But it's something to think about.
I tell you my experiment.
Okay.
I used a wine cork and then opened the hole in the middle of it. I placed a match, and I placed the match and the cork in the middle of the microwave oven, and I put the match on fire, and I placed a jar on top of it and put it on higher voltage overall. And you'll see, according to your positioning, you'll see a blue plasma, a very concentrated, very high concentrated heat, all together in that microwave. Just please don't try it. I mean, I don't know who's listening right now. I felt instantly guilty by saying that, but this is something really strange. I tried it. It is interesting to see it's a blue ball of plasma accumulating inside the glass that you put upside down on top of that cork and the match, and it creates this blue interaction, color interaction. I don't know what to call it.
Yeah, that's basically what the so-called scientists would call a plasma. You can also take a grape or some other small fruity thing and split it open, put it in a microwave, and create an actual plasma inside your microwave. And it will, you know, light up and create a glowing ball of plasma that you will recognize as having lots of energy. Also, scientists have used an ordinary type microwave oven to create the world's first room or atmospheric pressure plasma ball. They created it in the microwave and basically opened the door, and it shot out this sort of a donut toroid.
That's right. That's what you see.
It only lasted.
Anyone can do it, really.
Third of a second or something, but it was a new world record for room temperature, room pressure, plasma sort of thing. And they're all excited. That was a year or two ago now. So but you know, kids at home, please don't do this with your mom's microwave, because it could make stinky things and cause
no,
all kinds of burned out microwaves and whatnot. So be careful, but there are, you know, you can look at what other people have played with. If you look on the internet, you'll find, you know, people have created little plasma things with microwaves. And the fact is, it's a handy thing for high intensity effects that way. And maybe there's some way that it could interact with the the plasma technology. I don't know. It just came to mind with me recently. So when things like that start bouncing around my brain, then I have to start playing with it and see what it's all about. So who knows? I'm thinking if you had, for example, what if you had the typical ball that we all work with, some sort of GANS ball, and maybe you had a little bubble in the middle of some sort, especially if you had it spinning, or perhaps it had some sort of material that was able to suspend a ball in there, suspend either a voidness in the middle or some particular gases you were interested in, a combination of gases, ganses, some sort of whatever you wanted in the middle. And all of a sudden that's in a microwave, that environment can produce special effects from that center area. So that would be the interesting thing to me, is that you might be able to create an environment that, for example, maybe creates rotation through the a certain kind of turbulence, or certain kind of we'll call it heating, but it's more of a vibrational effect with the with certain ganses inside. Maybe certain ganses go one way and the other ganses go the other way, or who knows? We haven't really gone into that world. And of course, it gets a little dicey. You have to know what you're doing and not blow up things. And steam can be a very expansive thing. If there's any liquids in there that turn to steam, then suddenly you've got something that could blow up your plastic GANS ball, if you had something like that, and that kind of thing. So you have to be careful and all that, but I'm just suggesting that it's an area that maybe we haven't looked at, that maybe could be looked at. Or maybe there's other environments other than microwave that we should be looking at. For example, what about a vacuum situation? We haven't really, like, what if we put that whole plasma battery concept in a vacuum, took all the air out, so there's no more matter level stuff interacting? Well, the vacuum is where the plasma really performs. That's its native environment. That's where it loves to be. So it's where it has what I call elbow room, where as Mr. Keshe says, one atom of hydrogen in the vacuum the fields can extend out a meter, into a meter circle around that hydrogen atom. Its influence can be felt. So, whereas if it's in a crowded environment with a bunch of other heavy elements and other things, like in our atmosphere or in water or something like that, then its effects may not be felt the same way. They wouldn't extend out. They wouldn't be able to be perceived, let's say. So the vacuum is a very special environment. That's what Mr. Keshe, that's what we concentrated on in the first Plasma Reactor Groups, was pretty much the science of how to create a good vacuum, and how to, all the latest gizmos and seals and gear in order to try to get down to that perfect vacuum. And that's what one of the devices in the background that you see here, my turbomolecular vacuum pump, I've got another vacuum pump as well, and so on. This is what the early experiments were about, to create a really good vacuum so you didn't have the matter level stuff interfering with the matter level stuff that you wanted to put in there, just the small bits of it, that so the fields of it could interact instead of the matter bumping up against matter. It's more the fields are interacting. So yeah, anyway, so there's other
Rick, you need a spaceship to go to the space to get your vacuum and all the experiments done.
Well,
so we need the spaceship really quick.
This is the thing, is we have to know about what it's like to exist in the vacuum and what it's like in everywhere else in the universe other than Earth, basically. Space and many planets and so on may have a vacuum type environment or some very thin atmosphere, and we have to learn what things do in that environment, like the way the fields interact, for example, and especially in the big ways of these magnetic fields that stretch over many hundreds of light years. They're connected over hundreds of light years, and yet if you were to try to detect them, they would be barely detectable. But at the same time, they have this huge influence of maybe causing the positioning of a galaxy and this sort of thing. So there's many things about that vacuum environment that's quite incredible, actually, when you start thinking about it. The way rays work, for example, the gamma rays and all these cosmic rays and this kind of thing. In a vacuum, they just go. But in the air of our atmosphere, some of these rays and particles just stop dead within a couple of centimeters. And yet, if they were out in space, they would just go for light years and nothing, never hit anything. And so on. It's a totally different space. Space is a different space than Earth. We have to have our protective environment, our oasis created around us as we go. Or perhaps we go in our soul and it has its own built-in protective package, space or non-space. I see, Jedi, you got lots of comments here. Maybe you want to say something. If you want to open your microphone and expound on a topic, please go ahead here. Anything to stop me from talking.
Hello. Hello, Rick. Hello, everybody.
Hi.
Hi. We were thinking about doing something to receive energy. Maybe we got the concept is totally wrong. It's not a bucket of water. So we don't have to fill it up and then to use the water. And then that is what we have been doing for the last, let's say, 10,000 years. So let's just try to field is there. So we shall use it.
Sorry, you broke up a bit there.
Yeah, it broke. Just a moment.
If you could give us that last sentence.
So, yeah, the last sentence. The field is there. The only thing that we should try to look for is tuning. Tuning to the kind of energy flux we are looking for. to devices and instruments, they work within a range. So not see or listen to or find the values that are beyond, build new devices all the time. So within that range, we can see the effects. And so we say we can use that kind of flux. Now we need a very wide spectrum scatter. We go up to maybe 300 terahertz nowadays. And so we have to study all the effect, the energy of the flux within a specific range, find out the harmonics. So we just have to fit our little device where there is the peak, and that is the energy. It happens all the time, everywhere. So we don't need to fill it up. We just use it. It's gone.
Yes.
Broken. Okay.
So
that is according, I don't know, if you have a such kind of device, let's say, then you should try to see the field, to see the energy. If it is an optical kind of device, if you want to listen to what is going on, or antennas. So according to the length, the wavelength, you shall see or listen. So it depends on the kind of senses you're going to use. You have to feel it. So you will use your hands. That is, again, something that was below, so infrared, etc. So it's a very low frequency. Or you could is very high. Or with a specific instrument that is going to study, for example, a spectrogram are used into images, 2D or 3D images. So you can see sound, and that's another way to find out if there are harmonics and where they are and what to do with them. So we're not using the ancient kind of really ancient way of thinking, an oscilloscope, let's say, which shows just the wave. I'm not looking for that little wave. I have to get a picture of waves working all together at the same time. Then you have an idea. I cannot study an image by looking at one pixel. I need at least, let's say today we use 30 million pixels, and that's a photograph. I have an image. When we understand, then we see the picture. So you say, oh, I like that the garden, go there. Okay, I move in that direction. Are you there?
Yep.
Silence. Yeah, okay.
Yep, we hear
so,
you.
According to the battery, there is a guy that patented one of these batteries, some sort, which you recharge something like 10 minutes using radio frequency, and this battery lasts 70 years. So it exists, it's there. Okay, it's hidden away somewhere, doesn't matter. But we made it already, we have it. But we are not filling up the bucket, we are looking for the tuning. We missed a very important, let's say, number of scientists that have been terminated. So we missed the knowledge of many scientists that worked on the sciences. And one day they disappear, and all the work disappears, and all their ideas. And so it's like just creating a puzzle, and we miss 80% of the pieces, and it gets pixels. And so the image is most of the time you cannot see it. You just have to with this imagination. We do it in codecs, codec, going to empty images. So you need within a JPEG, you need anti-aliasing to rebuild what is not there. So this is our scientific reality has been working on this anti-aliasing, trying to fix things, whilst it was cancelling information, erasing it. Now the trouble we are into, it is because the models do not fit, do not work. We feel that there is something wrong. We don't know where we went wrong, and so we turn the wrong way. Okay, I don't.
Okay, well, thank you, Jedi, for that. Those observations.
You got the idea. I mean, there are a few names. We should go back to 1600. We find black holes there. We find concepts that we believe are modern, contemporary ones. We find them in 1600. So there is something wrong. Our position, probably. We believe we are, we know. This is arrogance, of course. And a few that had this kind of access to this knowledge, and so they kept it for themselves. So that is the problem. We have to go back to go to the future. So just jumping up, down 400 years, at least 400 years, then in this cycle, you will find out that there are all the solutions are there. It is not Tesla. That is not the answer. Tesla studied the work of another scientist that was born in Ragusa. Find it. He wrote more than 1,000 books and 400 letters. Just find the work of this man. The name, of course, find it. That is data mining. That is the way we should look for things. How many are we studying this kind of topics? Okay, we are 1,000. Okay, 20 people, data mining. Let's find what this guy said. Boscovich, Ruggero Boscovich. Okay, that's the name. Find it. According to harmonics, there are names that we do not want to, let's say we fear them, probably. They are not into science. Why? We know why. So let's find the names, let's study, and let's see if the machines, the devices, what they thought, very very easy to note nowadays. We got all the instruments. I mean, they're not expensive. They had to do it in the solid way that time, those days. So it was brass, gold, platinum, metal. It was mechanics. Now we can do it if we go where. We just calculate it. It's there. It works. We got the solution. We use it. It's just tuning to the right frequency, that is tuning to the mind, to the soul of the scientists that found the answers a long time ago. So we have to tune to the frequency. That is still alive. This frequency, this teaching is still there. We cannot forget it. So there is a dampening field that is stopping this from just meeting our conscience. Once we reach the field and we feel it, and this works, okay, so we're not looking for it. We are practicing it. So it's called John Worrell Keely. And you know the other name. So these two are missing scientists. And we should just sit down and study what they said. Just this is respect, some sort of respect. Okay. Thanks,
right.
everyone.
Good point.
Thanks, everyone.
And yeah, I've brought up several times the idea of the first, well, I'll show, let me just show my video briefly here. We're probably done with that board, but yeah, let me just do it here. And oh, I see I can't broadcast without interfering with the screen. Okay, well let's see if we're done with the
Rick, could I stop sharing?
Well, if we're done with it, does anybody need anything off this? Are we done with that? Can we go on to another part of this or another topic or whatever? I guess so. Okay, thanks, Moshfek. Very interesting. Great stuff there. I just wanted to show this drawing I have from, I think it's early 1600s, early to mid 1600s. And this is the first form of electricity actually in Europe at the time. And this is not just electricity, it's actually, this is a plasma ball, more or less. This is a sphere, partially evacuated glass sphere on a shaft that's being rotated by this guy here, who's probably the slave of the house or the whatever. And he's cranking this big wheel and making this glass sphere rotate at a fairly good clip. And this woman, who's probably the patron of the house, or matron of the house, I should say, and she's got her hand against this glass sphere. And when you do that, it starts the sphere to glow. It'll glow and give off light. And through the friction of the, it's a triboluminescent kind of phenomenon, and it is able to essentially charge the gases inside when it's partially evacuated. Again, because of the vacuum, the partial vacuum inside of the sphere makes the gases really easy to ionize, to light up And just through the friction of the hands on glass is enough to do that. So what they would have with this arrangement is the lady would light up this sphere, the slave drives this, and the man of the house gets to read his new newspaper by the light of this sphere. This would be like the height of high tech at that time, you might say. It was so high tech that they took this sort of assembly around from town to town, and they would amaze people. They wait till it was dark out and light up this sphere, and everyone would freak out about that. And this came out before they even had batteries. That's the amazing part about it. They had a plasma sphere like that. In fact, I was holding this right over where the plasma sphere was. They had this plasma sphere before they had batteries, so they had no way of storing the electricity that was generated or storing the light or anything. It was just all in
Baghdad battery is since 5,000 years old.
Okay, good point. Yeah, but we don't know what they did with it. They may have lit something with it. Maybe they had other purposes for it. But this was in Europe, though. Europe was, remember, the Dark Ages. It was dark because they didn't have any light, I guess. But it was dark because it was suppressed. They had lost the technology of the East and of the, all of that was basically, suppressed by the technologists at that time. The church did not allow that technology to be implemented. So this was pretty radical at the time. And it took, I think, 1 or 2 decades after this came out that they invented batteries, and they started holding a charge in batteries. And then they invented light bulbs and so on that could be lit from batteries. And this whole technology of the plasma basically faded away, other than Nikola Tesla got into it quite a bit because he was experimenting with basically fluorescent type bulbs at that time and thought that was the way to go instead of the incandescent bulbs that Edison was working with, that he thought, Tesla thought it would make everybody go bald. And maybe he was right, from the rays from the incandescent bulbs. But it's interesting that especially in light with what Jedi was talking about in terms of the suppression of technology and so on, and only certain technologies have been allowed through time. Again, Tesla's the test case on that, the classic case, you might say, of suppression of technology. He wasn't allowed by the industrialist groups at that time to progress with his technologies in the way that he wished for the benefit of mankind. That was against the benefit of the few, so the few decided that they would not support that, and they didn't allow him to do banking and that kind of thing. So that has existed all the way through. There's even one theory that Nikola Tesla was actually snuffed and didn't have a natural death. So that gets into a whole other thing. And then if you look at other scientists that we've lost the knowledge from along the way because of their being suppressed or under-supported or outright killed, poisoned, and so on. And this is a big issue, and I think you're going to find that it becomes a big issue in the next few weeks here as well. So we'll see how things happen, to have respect for those who are on the leading edge of science and to give them the respect that's they should have for being out there and trying to help others and improve our lot on this planet. Anyway,
I see an orange ball there, and it looks pretty bright from this perspective. I wonder if it has any range of interaction and some understanding beyond that while we're talking about interaction. I believe it has, but I'd love to hear your perspective on that.
Goes back to what Jedi was talking about there in terms of what you're measuring and what bandwidth you are wishing to measure, first of all, or capable of measuring is the other thing. So in other words, what you're seeing right now, at least when I look at, when I perceive on my screen what you're seeing, it looks like an orange ball, and it's kind of got a ring around the edge here. There's like a red ring and an orange ball in the middle, and yellowy orange. So, but that's a totally different perception than I'm getting right here, which is it's not at all the same color. It's sort of more reddish, and it's all sort of the same color. It doesn't have the blotches in it and different things going on. It just has the sparks, and it's doesn't have the red ring around it. It's totally different, as I've shown before. So there's those fields. There's light light rays that are being given off from this. So there's rays coming from that central point, let's say, and that's what we perceive as light. It goes through our eyeballs, through our amino acids in our eyes, and gets transformed through signals and so on, becomes an image in our brain, and that's what we think something is, just because of the light reflecting from it. And we're often fooled. That's what illusions are good for, and magic and TV and everything else. I mean, we look at pixels on a TV screen and we really think that's the things going on are real. And especially if it's a soap opera, there's certain people get really into it, and they actually believe that these pixels are real, that they're real people. And they're actually pixels. They're pixels people. They're pixel people. They're not actually real on your screen. But we believe it because we allow ourselves to identify that those images are real. In fact, they had tests with people that weren't exposed to a modern culture, like come from the Amazon jungle, and it's their first time seeing any technology, and they looked at a TV and they couldn't tell what the images were on the TV. It was just a blur of, they couldn't discern what things were because they only saw different blotches of color, or blotches of things moving perhaps, but they couldn't discern a human as opposed to a rock or something else, because it was two-dimensional and they couldn't accept it. They didn't believe that what they're seeing was the same as what we believe that we're seeing. So it's a learned thing, this this idea of perception, and we have to think about that a bit. For example, as I've shown before several times on the Plasma group here, when this crystal radio is hooked up to basically the sound input of a computer, and then what this radio hears is played back in live real time, then you would hear the different basically it's like a barrier or different levels, you could say, of intensity coming from this plasma sphere. And so the closer you get, the louder the signal gets generally, until you're very close, and when the signal can sometimes completely die away when you're right next to the plasma ball. And then the greatest intensity is actually a few centimeters out, and then there's another Coulomb barrier, you could say, out here that there's greater intensity again, and then another one. And the fields change. If you get close to it, then it changes where the fields are. So the interaction of our bodies being so absorbent of radio fields tends to change the actual perception of the instrument that you're using. And if you touch the instrument or touch the antenna, that changes it as well. So there's so many variables, and you're just looking at electromagnetic waves. Of course, the crystal radio is special in that it can perceive a very, very wide bandwidth of signals, actually, other than AM radio, especially if it's tuned like this one is to the Schumann Earth frequency of 7.8 hertz, and rather than 540 kilohertz. So you end up with different fields are given off. Even this simple plasma ball here gives off a wide spectrum of fields, and they can have, if it's interpreted by sound, it'll have different sounds all the way through and so on. If it's interpreted in another way, for example, with the little pens that for detecting voltage, they can light up around this as well. So you're converting the fields into a light image in that case. Or if you were to have a filter of different kinds, you could have a different filter that would show this as a different color, or perhaps only allow certain electromagnetic fields to come through. So there's all these different ways of measuring. And then, of course, what is the effect on the human without having all the devices to measure? That's another thing as well. You know, what happens when you actually touch the unit, and it changes the nature of how it works, and then what's the you know, what is it doing? What does it feel like, and to interact with a plasma ball? So all these things sort of come to mind in terms of what is coming out of that. So it's kind of a matter of what you see is what you get. What you measure is what you get. And according to any particular way you want to measure is what you get. So, and then it becomes a matter of what do you really want? Because otherwise you could have, say, 1,000 instruments measuring this one plasma ball. In fact, I was just thinking earlier, there's that video we've mentioned before several times, the Sapphire Project, I believe it's called, SAFIRE. If anyone wants to look it up or find the link. Sapphire Project is basically this, they built this plasma vacuum chamber. We talked about a vacuum and vacuum chambers earlier. Like Mr. Keshe works with a vacuum chamber originally in the original patent. And that's the reactor is a little vacuum chamber. And so they built this vacuum chamber in the Sapphire Project. And then they created a plasma inside of it and had some very interesting observations. This was just in the last year. It was a whole project they put together and financed it and everything to do some really basic research into a plasma. And what they discover is quite interesting, very similar to the research that I've done with this and this, in determining, like, there's a field here, and another field, and then nothing. And I go, what? That's crazy, and nothing, and then and then. So there's these layers of fields, and it's a double, what they call a double layer effect in plasma. So they discovered they might have 7 or 8 of these double layers in their Sapphire project. And each of these layers that comes out, like, it's all around the globe that they have. It's a similar globe to this, a little bit smaller. And it was inside the vacuum chamber. So that was their electrode, you could say. And it gives off these fields. And so they had, I think, let me see, it must have been at least 20 different measurements they're making on the plasma that exuded from this instrument that they had set up, this plasma chamber, and they had different things. And one of the things they were measuring was the temperature, because they were putting, I think it was a couple thousand watts into this unit, and it gives off these fields, and it's glowing, you know, it causes the gases that are there to glow and so on. So it's got these gradients of these double layers coming off, like boom, boom, boom. And they were measuring it with this very sensitive temperature probe made out of, I believe it was titanium, the highest temperature metal that can take the highest temperature. And they stuck it in there, and they were measuring the temperature, and suddenly the tip of the probe just melted. And they blew their $5,000 probe up. And so they had to go back to the manufacturer and say, oh, geez, we kind of blew up your probe here. I said, well, really? That must be over 10,000 degrees. How did you achieve that? Well, we don't know. We expected only to get 2,000 or 3,000 degrees, and we don't know. We have to probe and find out. So they got another probe, more heavy duty probe, and they ended up melting that and totally crystallizing the titanium inside the probe and so on. And so it was very mysterious. But what was interesting was right next to the electrode was not a very high temperature, but outside in these layers was a gradient that had very high temperature gradient in each of these layers. So it would go from high to low temperature and high to low temperature, actually from low to high, low to high, low to high, through all these layers. And this was part of the fascinating part, that the initial electrode didn't have all that temperature on it, but it could produce environments around it, a controlled environment of more intensity than what was on the surface of the actual matter level material. So they made a number of discoveries about being able to control those fields and the interaction of them and how hot they were and so on. Much, much hotter than they expected. Goes up to like 30, 40,000 degrees or something like that. So it's very interesting, and the idea of fields in general and how they replicate themselves as layers. And we see that in lots of different things. And basically it's a form of resonance, but I don't know if we can call it resonance. It's there's probably some natural laws involved as far as the layering goes, and the distance between layers, and perhaps the whole thing. But as Mr. Keshe says, it's not about the frequency. It's not. We're not trying to measure the frequency of the plasma ball, for example. It's not about that really. because these different layers have a whole range of frequencies in them. When I measured with this, it would go woo, woo. There's a whole range of frequencies. It's hard to measure one frequency when there's things coming and going all over the place. So I don't know if that made sense to people, but I think I'm done that spiel now. Okay, any questions, comments, or somebody want to show something? Okay, I'm checking for, oh, we've got a question here I'd like to bring up then. So from Anuj, actually, I think that's the way you pronounce his name, I'm not sure. He wants to know more about the CH3 and hemoglobin and how that, let me see if I can get it phrased properly here. I think he quotes something about the man in the iron sways amino acids. In plants, the magnesium sways amino acids. For this reason, the hemoglobin is a perfect amino acid source of creation. Mixed 50% hemoglobin, emotional, directed at the physicality, copper, in order to regenerate muscle tissue, and another 50% of hemoglobin with the maximum potential emotional of zinc. But now, and Anuj says, Mr. Keshe says that the CH3 in hemoglobin has everything, the copper, the zinc, and amino acids. And he'd like to clearly understand whether the CH3 and hemoglobin together is good for people with issues, or is it something you want to keep away from? How would you use it? And this kind of thing. I don't want to get into trying to play doctor and health applications and so on, but maybe there's a way that someone can explain the interaction of the interaction of the CH3 and hemoglobin in reference to that, how it could be used, or what is the concept behind it, perhaps.
Hello, Rick.
Hello.
I would have a question here. I'm not sure. Does the hemoglobin GANs related to the person who does the GANs, or if I make hemoglobin, I can give it to somebody else to use it? I never produced it.
That's a good question. I think it would depend if you also, like, part of that is there's one talk about putting part of the blood in with the hemoglobin and amino acid and whatnot. And people have talked about that as well. And that starts to enter into the addition of one's own personal materials, matter level, stuff into the environment of the reactor or of the experiment. And that can or cannot be beneficial depending on the situation. And it gets into some ethical things as well, and so on and so forth. When we start creating life forms, which is essentially what gets, what we're talking about here, then it gets into a bit of a dicey ethical issue. And what is it that your intention is to create, and how can we help others without sort of in a way being overbearing or putting our own stuff in it, which might tie back to us in ways that we don't really wish for, and that kind of thing.
Exactly. And I believe we can do these things more focused to their purpose, to be more personalized, let's say.
Well, for example, if you're creating something for yourself, some sort of reactor that you wanted to interact with, or some particular GANs for a particular affliction or something like that, then you might want to add part of your DNA into it to be kind of a guide or a starter for something that you wanted to interact with. Or if you're possibly in the more advanced stages, if you were to interact with a spaceship, and maybe you were the captain of your spaceship or the navigator of your spaceship, let's say, and you needed to interact directly with the star drive of your spaceship, and we didn't have fly-by-wire or fly-by-cable or any other connection to the engine other than through our emotions.
Yes, wireless connections.
Yeah, completely wireless connections through, beyond nervous system connections to the emotional field connection, essentially. It may be necessary on some level to still have that connection, that DNA connection to the ship. I mean, this is what what's his name? The name's just escaping me. It'll come back to me in a minute here. David Adair. David Adair is the fellow that is getting some PR recently, as his story goes back into the 1970s, where he was apparently in Area 51, where he was invited as a young rocket scientist, probably the youngest ever rocket scientist. He was doing rocket science, and when he was 12 and 13 years old, basically, as when he was building NASCAR engines for his father, who was selling them to Richard Petty. But anyway, he was invited into a hangar of Area 51 where this apparent alien ship was housed, and he got to investigate it all and check it out for the military that was trying to groom him at that time for his rocket engine. And his big thing was he realized that this alien engine that he was checking out, how it worked, and he understood it on a fusion level, how it worked and so on. He realized that he was in emotional contact with this thing, and that it had actual feelings, and that it was responding to the people around it, and that it responded a certain way to certain individuals and a certain way to him, and so on. And that he was wondering what was going on. There's a big gaping hole in this thing, and he knew that it had been like shot down or something, or apparently seemed to have been captured or something. And anyway, it got into a bit of a hassle with him, and he ended up, the way I understand it, he ended up blowing up his rocket engine, sabotaging it deliberately so that the military wouldn't get his rocket engine secrets, because it could go way faster than any of the other chemical type rockets at that time and since. Had so much acceleration that the rocket tubes at that time would collapse under the extreme acceleration, so they had to build new rocket tubes in order to even run the engines. Anyway, the main idea among that bunch of words is the idea of the connection, the emotional connection with the actual power source or propulsion engine, the reactor, the main source in the craft, you might say. So to keep that connection and control, how would one do it? And it makes total sense that it works on a direct emotional field connection. Even if you look at the way our rough technology in planet Earth is going, if you look at the connection with the original cars and mechanical devices, it was always with mechanical things, steering wheels and pedals and things that interconnect with our body. And more in the more modern cars, which are becoming increasingly so self-driving, and it's becoming, the new Google car that they were experimenting with had no steering wheel and no brake pedal. And so that takes away the physicality interaction, and all you've got is, take me to 15th Avenue, please, as fast as possible, or as slow as possible, depending which way you wanted to go. And so you're interacting probably with your voice or with, directing your fingers a little bit to tell this machine where it is you want to go. And eventually you won't even have to say it. It will know where you want to go, and either know your habits or know your thoughts. And it'll automatically take you to where you wish to go. So we're actually very close to that, and have the technology now to be able to control machines with thoughts, and have advanced ways of doing that now. So it's not a far cry to think other technologies, other civilizations, maybe, even if they were 100 years ahead of humankind, they would be so much more far advanced when we consider what 100 years of our time right now could mean. Not to mention if they could be 1,000, 10,000, or 1,000,000 years or more advanced, then physicality stuff is pretty much gone by the wayside, probably. Okay, I think I talked too much. Must be getting late. I'm getting giddy and talkative. Does anybody else have something that they can insert about this hemoglobin and CH3 understanding? Specifically, I'm interested, like we have learned in some of the health teachings about not to use CH3 and for CH3 plasma water and that kind of thing. So for it's counterindicated in terms of cancer, for example, whereas the CO2 GANs or zinc oxide might be more useful. So why is it that there might be benefits with the CH3/hemoglobin combo? Any comments on that? And Anuj, is there anything that you'd like to say about that, or can you clarify my clunky way of saying it, perhaps? Not sure if you're able to. Maybe you want to.
Hello. Good morning.
Hello.
This is Lawrence from Hungary again.
Hi, Lawrence.
I would like to share my my propositions again. And I think anytime when we have a beneficial effect, we have the plasmatic field of the neutron involved. And whatever we have around it, how we may call it, is the GANs or the container which is around it. It's like the soul of the human being has the emotions and the body as a container around it, which act as a filter. So the source of the energy is the plasmatic neutron, and all the others are the names for the filters that we use.
Okay.
And I have a question which is related to all these topics we've been talking about, namely, where does the pull of the vorticular movement, the vortex, come from?
Where does the pull of the vortex come from? Is that what you said?
Yes. What is the source of the energy that creates the pull in the vortex?
Which vortex are you referring to?
Any.
Okay.
It could be air, it could be water, it could be plasmatic. Just, because like last time when we were talking about the isotopes, and I wanted to highlight that the creation of the plasmatic neutron should be a quite simple thing, because nature does it everywhere. And we, with our technological minds, think that we need...
Here's a good example. Then there's a huge hurricane coming up that's about to hit the east coast of the U.S. And of course, there's an eye in that hurricane. It's very distinct from the satellite pictures and images and so on. And it's a huge, vortex. But at that center eye, if you were in the very center of it, you wouldn't be feeling all the wind and so on. It would be essentially the stillness in the very center core. So in the case of that hurricane, it's the outer winds that create the core, or it's actually more of the temperature difference and so on that's involved in gradients and all that kind of thing. But at this is what I'm trying to get at is that center core is what we see is like, whoa, that core is so intense. Everything is focused in around that core. It's all rotating around the core. But yet the core is the nothing in the middle, is like the neutron in a way. It's so important. It's the kernel of everything. And yet it's a different place than it has different qualities than the rest of this entity that's involved with the actual vortex part of it, the movement part of it. There's a saying, the center of the cyclone never spins. center.
It's what I wanted
the field never spins.
It's exactly what I wanted to point to, is that at the center of all these phenomena is that plasmatic neutron, and it has such a gravitational effect that it pulls in things. And in the center of that calmness of the storm, I think we have a huge vacuum. That's the emanation of that pulling energy that feeds the storm or feeds any vorticular movement. So whenever we see a vortex in the river, whenever we see a storm, whenever we see the drain in the bath tube, we have a small vacuum chamber created out of materials of the surroundings. It's the scaffolding again for that plasmatic neutron. And I think it's that pull, it's the source of the gravitational pull there is exactly that field. And whenever the point is to create it in a stable manner. So whenever we have ganses, we know that we have a filter around that plasmatic neutron, but it's in a stable configuration. It's not temporal like in the bath tube when we pull the drain, let the water flow, and then it goes away after some time when the materials are not in that particular shape and position and flow when they were before, when the vortex was created. So I think we've been talking about, or you've been talking about these nanotubes or tubes that have been nano-coated. Whenever we say, for example, take a flute, this musical instrument where you blow air into, because it's made of wood, it's made of ganses, if we want to be really serious. But with the shaping of holes, or with the distance on, well, the shape, the length of the flute, the shape of the hole in the center and the distance of the different holes on the side of the flute, we create different sounds with it. We also have been talking about this sonoluminescent experiments where different sound emitters create a little bubble. The thing I wanted to go out to is that with music, because music in some way affects our emotions, and music is based on ratio, like plasma does. If we smart and knowledgeable, could create instruments that, like the luminescent bubble, create the plasmatic field strengths of the neutron when being played with by means of their harmonics. And like this, we could create. We could even do it with our own sound, like with our own thoughts in a higher level, but we can even use our own voice and sing, for example, with each other, 3 or 4 people coming together, creating a star formation. And then in the center, if they can manage to create the plasmatic field of the neutron, this pull on the plasmatic level, then they would create a field emitter, just like we do now with our technological devices based on matter.
Yeah, we call that a band.
Yes, we call it a band, and we've been doing it. It's like the Captain Obvious thing when Mr. Keshe said that we've all been nano makers since we fried the meat.
Yeah.
So I think nature does all these magical things, what we call magical, or we call very sophisticated, because we now call it plasma and field of the neutron, by default all the time, else we wouldn't be having living entities, you know, beings and creatures and all the other things that we have around. It's always the plasmatic neutron in the center, and then pop, there's a universe around it. There's a being around it. There's a human around it, an animal, a plant, or whatever we may call it. So it's got to be easy. I mean, like, as easy as whatever we see around. And this is why, or when Jedi said we should be changed, I think our emotions and the way we look at things is basically the filter, that's the limit that we created for ourselves. It's what the ancients call the veil that we have in front of our eyes. Because, you know, just like we have the soul in the center, our eyes are filters for our soul. We can see when looking into someone else's eyes what kind of emotion they have. So basically, we've been filtering our understanding of this workings of the soul by the way we've been looking at things and thinking of things. So the only thing that we really need to tune into or work on is our emotions and the vortex of our own soul. Thanks for listening to my speculations, dear friends.
Well, they certainly resonate with me, and I'm sure they resonate with others as well. So thank you very much, Lawrence, as always, for your observations and various other things that you've done. Anybody else want to weigh in on that topic or some other topic here? I'd like to mention, like Alper mentions in the chat here, music is based on emotion. And we mentioned music. And there will be, I'm pretty sure there's going to be, I've been asked to host it, a private teaching workshop, probably be once a month, I think. The first one coming up in October with music, and it might be a combination of music and art. It'll be private teaching class in the Keshe Foundation Spaceship Institute, private teachings. It'll be on Fridays, and I'm not sure the time right now, but I'll publicize that later. And is to put together music and art for the Keshe Foundation is the idea. And we experiment with different things and have a lot of fun with this idea of music being based on emotion, and how do we elevate others with music, and how do we connect with other beings with music, and so on and so forth. So we've got songs planned such as the bird song, using only bird sounds to communicate, to be a tribute to the bird community, and other sort of very much niche music, you might say. But we are trying to come up with music that can be also used for background music for some of the Keshe videos or other things during the breaks in the Knowledge Seekers Workshop and that kind of thing. So that's if you have to become a student in the Keshe Foundation Spaceship Institute to do that. And now is a great time to sign up to be a student in the Keshe Foundation Spaceship Institute. And the private teachings start next week, next Monday coming up, this Monday, you might say. Monday, I think it's the 17th. And there's a bunch of new teachings ready to go, and it promises to be another semester of fun. People actually like the classes, and it becomes a fun community of people interacting and giving their questions and comments to the teachers that teach what they know of the technology, the plasma technology. So, invite people to do that. You can go to the kfssi.org website and click on the appropriate place there. There's places you can sign to be a student, as well as on the main Keshe Foundation support site. You can link to it there as well. Okay, anything else anybody'd like to bring up? Maybe it's time to think about wrapping things up here. It's almost 4 hours coming up here. Don't like to go over 4 hours because it messes up our streaming. Hearing the sounds of silence.
This is Moshfek again. Talk a little bit about the CH3 question that was raised a little bit back.
That'd be great.
So the CH3, you can use CH3 in different combination of ratio with CO2 and zinc oxide. And in particular, the zinc oxide in which you make hemoglobin creates a special connection. And one of the tests which I have done, and I do treat people with energy deficiency with some CH3 in there together with zinc oxide and CO2. So this is one of the applications that I have done. But in addition to that, since there is an emotional connection, there is an interesting effect which one can observe easily if you put CH3 and zinc oxide and carbon dioxide in different ratio. And I think one needs to do their own experiment. You can create, and especially if you do it with, let's say, a blender, some sort of rotational device, which homogenizes the plasma. And you can taste different taste depending on the ratio of zinc oxide, carbon dioxide, and CH3. So one of the things that I have tested is that sweetness of different type. It's not different type in terms of intensity, but rather kind of like you can get minty taste, you can get taste of honey, and various other combination of these. So this is one way of identifying, the emotional component of our eating. We don't just eat for our nutritional energy, but also the emotional component. So this is one way of observing how CH3 can be tuned to different emotional satisfaction that we get with food. And with hemoglobin, zinc oxide in which you made hemoglobin, it seems to make the connection easier. That has been my experience. Of course, you use, those amino acid on top and with little bit in there. And, the mixing of the GANs is that you start with the lowest strength one and then go up in strength, and then you blend all the combination together. So here are some pointers to try out various things. And I haven't done this, but this is one of the experiments I want to do is with peppers and GANs. So see how that test can be modified. But, these are fun things one can do. Hot pepper. But, I have seen the sweet taste from CH3, which is kind of like CH3 you can think of as a component of the sugar. So as you mix different ratios, you can see the taste changes. And this is very fascinating. And you can observe the taste changing as the ratio changes.
Yeah, when you mention this really keys it off for me that this could be an answer to Anuj his question, how to judge for oneself whether some formula is appropriate to oneself. Like if you're making your own medicine, how do you know it's good for yourself? Well, maybe just a little taste of the plasma water would give you a sort of an understanding in itself whether it's beneficial or not. The body will know, let's say. So perhaps that is the best test of the plasma fields in a way.
There is one more thing I wanted to mention, and this is the thing, is that it actually, you have to measure it to, I measure it to the level of 0.1 milliliter in, let's say, if I put, let's say, 5 milliliter of plasma water, the ratio and the taste change at the level of, I mean, I haven't gone below that because it's hard to measure, but it can be done, 0.1 milliliter level. It is very sensitive, actually. It changes a little bit, makes a difference. So be careful in your test, because otherwise you'll be all over the place. So this has been my experience. I'm just sharing what I have seen. And this is a fun test one can do and get an idea of how plasma affects the emotion of taste. And so anyway, it's actually very fascinating to do this test.
Yeah, that's a really good point, actually. Maybe that's the way to proceed, in a way, to find out what the correct ratio is for oneself, or to give some direction that way. Interesting. Thank you. It might be
another thing. There is many guys here, many guys, not girls, so I'll give you a hint. I mean, Mr. Keshe, in one of the knowledge seekers, I don't remember, it's 100 something, 105, 15, somewhere there, but talked about zinc oxide and the zinc component in Viagra. So when you do this test, watch out.
Okay.
That's a fun part. Another fun part of this one.
I don't know if we need to report those practical results or not, but perhaps they can.
Yeah, we know. Rick, we may have to create a private room for that one.
Private men's club for that, or maybe it's a private women's club.
I'm not sure which one I want to go to, though. Now that you mentioned.
Yeah. No, that's the pros to do all the professional experimenting, and a lot of these things are not recommended for household experimenters. And we do recommend you consult with actual real doctors when necessary, with real problems that make sure that you don't bypass some of the regular systems if you need that kind of thing. Don't throw out all your meds yet, but we do like to experiment, especially in people in this group. It's part of our nature and part of the way we roll. So a little dab will do you. Okay, perhaps we'll wrap things up here now. Any other last comments before we close? Got the Knowledge Seekers Workshop coming up in approximately less than 22 hours from now. And looking forward to that. And what else? There'll be a One Nation, One Planet, One Race, I believe, coming up on Tuesday of next week, as well as a full roster of languages and public workshops and all of the private teachings as well. Lots going on in the world of Keshe coming up. Oh, also check out the Plasma Times. It's a great little read. The latest September issue is out, and it's chock full of really good little details and hints for people that would like to know more. And if you would like to contribute to an issue of the Plasma Times, that would be a great way to pay back to the Keshe Foundation and to show your appreciation for whatever aspect that you might like to bring out in the Plasma Times. And you can contact them through the support contact form or other ways that just let them know, the webmaster and so on, to let them know that you would like to contribute to the Plasma Times. Or you could be a transcriber or participate as a host in the private teachings, and lots of other opportunities are coming up to work with the Keshe Foundation and to help with this transformation, I believe, of the planet and its inhabitants at this time. So let's leave it at that for now. Thanks everybody for participating and listening and being part of the Keshe Plasma Reactor Group today. Lots of great input and ideas and experiments that we can work with. So bring back your experiments next week, and we look forward to another session as usual. Okay, this is Rick for Keshe Plasma Reactor Group for Wednesday, September 12th, 2018. Thank you, everybody, for attending. Okay, I'll end the live stream to start with. And